Houston integrity for camera serial numbers.
Ready to copy.
Hey Jenny, these are card numbers for the various positions. For the long lens on the D5, we will have individual cards. Victor's 1008, Jeremy 1019, Reed 1012, myself 1015. For the Z9, we will have one card that is dedicated for today, serial number 1007. For the cabin camera D5, we will have one dedicated card for today, serial number 1022.
All right, Christina, we copy all. Thank you.
We just realized that we have Earth out window 1 and Moon out window 2, and Earth out window 4 and Moon out window 3, and it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reed.
Those are some of the communications we're excited most about today. Commander Reed Wiseman calling down their view right now, obviously a little bit different than what we can see from the solar array camera. They are looking through the windows of the Orion spacecraft, able to see at the same time Earth and the Moon. You also heard NASA astronaut Christina Cook calling down some of the cameras that they will be using today. Crew is in that cabin configuration portion, and we expect the lunar flyby observation period to start just about 20 minutes. Checking in on Orion's distance and speed, they are currently traveling 1,071 miles per hour, 249,159 miles away from Earth, 11,293 miles away from the Moon, and continuing to grow closer. At closest approach to the Moon today, the spacecraft will be just about 4,070 miles away from the lunar surface. This will be during our loss of signal with the crew as they travel behind the Moon, and we will await their return to get the official number for you for how close they come to our lunar neighbor. Inside the cabin today, the lunar targeting package is the primary tool guiding the crew observations and consists of two key components. The lunar geography review helped the astronauts study major lunar features in advance and help learn how to orient themselves during the flyby. Because, of course, the moon is not actually labeled like it appears here when we look at this map. The lunar targeting plan provides a detailed timeline of observation targets, background science context, and specific instructions for the pictures the crew should take, as well as the verbal descriptions that will be helpful to the science team reviewing them later. This is a screenshot from their lunar targeting package, and a screenshot specifically of that lunar.
Integrity for attitude.
Go ahead.
Hey, Jenny. Understanding we are in final attitude now for the lunar flyby, would it be possible to pitch the vehicle down 5 degrees? That would allow us to get the D5 long lens flush and have the least amount of window distortion.
We're checking.
That call from Christina Cook, NASA astronaut and mission specialist on Artemis II.
Copy.
The Orion spacecraft is positioned in a specific attitude to allow the crew to best see the moon outside of their windows today for this imaging opportunity. That call was a request for a potential attitude shift just slightly, another 5 degrees, to give them a better view and to give them a better opportunity to use their long lens camera. They'll also be using that lunar targeting package we were discussing. I am following along with that real time, so I'll be able to share with you exactly what targets the crew is looking at and when. They also trained with a lunar science passport. It's a little reference guide used on Earth to reinforce recognition of key lunar features. It is not on the flight, but it was a significant study tool for the crew to get them ready for launch. The apparent size of the moon will change throughout the flyby, and it'll appear roughly like a basketball held at arm's length at the crew's closest approach. That reinforces the need for careful planning and practiced observation techniques.
Houston, integrity for timeline.
Go ahead.
Hey, Jenny, just to make absolutely sure that we start observations when expected, we are showing in Optimus that observation time starts in about 15 minutes, and in LTP that our first target, discussion 1, starts in about 29 minutes. Can you confirm you'd like us to start discussion 1 in 29 minutes at 1900 GMT?
Christina, we are tracking that discussion 1 should start at 18:45. That's 15 minutes from now.
Okay, copy all. It may be a granularity issue with LTP, but understand that we start that observation in 15 minutes, and I bet when we get there, the green line in LTP will match the start of the white band for discussion 1. I think it's just a matter of the labeling and the granularity. Thanks for confirming.
Copy, and we'll look into that a little bit more on our side as well. Christina, can you verify for us that your green line is moving on the timeline page of your LTP?
we're good. Looking closer, I see the labels are just not aligned with start or end times of the white visible bands. It fully makes sense now, so I think we are all set. We'll look forward to starting some observations in about 13 minutes.
Copy. Thanks, Christina.
As you heard discussed, we are expecting the crew's observation time period to start in about 10 minutes. First, they'll be conducting a warm-up, warming up to their science observations of the moon. They'll be discussing with each other, helping each other orient using the major landmarks that they've studied, asking what is familiar.
If we roll left, port 5 degrees, that would get the moon closer to the left side of window 2.
Copy, Victor. We'd like to know if it's pitch and roll or one or the other.
Jenny, we actually thought you already put the pitch in. Had the pitch been put in already?
No, we need a little while longer to talk about it.
So, Jenny, I guess what's happening is just as our orbit's changing, where it is in the window is changing, so maybe these fancy little adjustments aren't worth it. It's going to continue to move in the window. Or is the spacecraft going to keep the moon at the same point of the window if we adjust the attitude? I assume the previous.
Right now, we are pointing the center of the window to the center of the moon with 2 degrees of deadband.
The conversation you hear happening now between the astronauts aboard Orion and Artemis Mission Control here at Johnson Space Center in Houston, Texas. They are in the center of your screen, seated at the CAPCOM, or Capsule Communicator Console. That's Jenny Gibbons, Canadian Space Agency astronaut and Artemis II backup. She was also the lead Capcom for Expedition 63 aboard the International Space Station. The crew is requesting some attitude changes to the spacecraft to allow them to better image the moon, our priority for today. Of course, those have to be discussed on the ground before they are put into work aboard the spacecraft, so the team is taking some time to do so. You also heard Gibbons reference that we are into dead bands. Dead bands are essentially keeping us in the lane in which we're traveling. If you're familiar with lane assist in your car, very similar in this case. We are now 10,870 miles away from the moon, traveling 1,066 miles per hour and 249,390 miles away from Earth. Again, we recently surpassed the Apollo 13 distance record of farthest humans have ever traveled. And upon calling down some words during that milestone, Canadian Space Agency astronaut Jeremy Hansen noting that he hopes that this record that they are setting today is soon broken by future explorers. This is Artemis Mission Control. We are standing by for the beginning of lunar flyby. Expecting that to start in just a few minutes when the crew will begin a warm-up discussion preparing for the day. They will be capturing images along while discussing what they find familiar about the moon and what looks unexpected to them. Again, just minutes away from the official start of lunar flyby, or when it is timelined for the crew. We are currently 10,726 miles away from the moon. This view on the left side of your screen coming from the camera on one of Orion's solar arrays. Other conversation points while the crew are getting ready for their flyby today. They'll be looking to orient themselves using major landmarks and annotating their observations along with their discussion. They'll have 10 minutes for that warm-up discussion.
Houston integrity. We have two folks at the window deep in discussion talking about all of the awesome features that they're seeing. We just had a huge moment realizing that Hertzsprung is about the same size as our incredible Oriental. We're really excited about this target that's kind of new to us. We're orienting on things like how we talk about albedo, finding some of the prevalent things that we're used to from all of our training, and just overall taking in this view. We also are noticing that the moon is still getting noticeably bigger as we go, even when you're watching it continuously. It's great to see these two guys get warmed up.
We love the report, Christina, thanks, and you nailed it on why we added Hertzsprung. As you'll see in the prompts, we're looking for comparisons to the comparatively much older Hertzsprung compared to the younger Oriental. Great words.
This is Artemis Mission Control. That was the voice of Dr. Kelsey Young speaking with the astronauts aboard Orion as they begin their observation period and lunar flyby. NASA astronaut Christina Cook reporting their view of Hertzsprung Basin. The team here is looking for centered images of the basin at a full zoom, and they're hoping that the astronauts can image and describe the inner and outer rings. This is considered a degraded basin with a floor, rings, and ejecta compared to a younger Oriental basin. We spoke earlier with Julian Gross, the Artemis Curation Lead, about some of the terms we will hear the crew use today. One of those just called out, that's albedo, looking at surface brightness, or the amount of light a surface reflects. A few more terms that we hope to hear today during the crew's sit-reps or situation reports include embaying. This refers to one feature that surrounds another. That usually is a higher relief feature.
Houston Integrity, one report from the crew at the windows. We can actually see the moon and Earth at the same time right now. It's interesting because the Earth looks way brighter, so the Earth itself seems to have a much higher albedo than the moon. We think this is independent of our eyes focusing because, of course, the Earth is much smaller than the moon in our view, so you could think that your eyes focus for the darker sky, and that it means that it only has apparent brightness more than the moon, but since we're seeing both in the same view, we do think that this can be inferred as the Earth as a whole has a higher albedo.
Great observation, Christina, and reminder that as you're starting to look for those subtle color and albedo variations on the moon, the relatively bright albedo Earth might make those a little bit difficult, but as your eyes continue to adjust, we expect you to start to see more nuance on the moon. Thanks.
Great call. Thanks for the reminder.
We're all going to be experts in lunar terminology by the end of the day. Another one we expect to hear is mare. These are dark regions paved or filled by volcanic deposits. You also can hear them called seas, oceans, lakes, or marshes, or other bodies of water. Again, we are live in Artemis Mission Control, but on the right side of your screen, that is the Science Evaluation Room, team members who have been preparing for this day for years. The crew has significantly darkened the cabin of Orion. This allows them better views outside the windows and fewer reflections from inside. They reported being able to see the moon and the Earth out the same window at this time. We are really hopeful to get those photos. Right now, this view on the left side of your screen coming from a camera mounted on one of the solar array wings on Orion outside the spacecraft. Crew is equipped with 80 to 400 millimeter zoom lenses. The team continues their warm-up discussion. I should say the crew members aboard Orion continue their warm-up discussion. However, they are about to be prompted to move on to discussion number 2, which is near side and far side. some of the things that they are looking to capture, the ground has prompted them to photograph anything that stands out to them and to compare the near side versus the far side mare in color, albedo, topography, and texture. They also want the crew to compare the appearance of rayed craters in the near side mare versus in the far side highlands. Of course, a reminder that some of the items that the crew, or some of the landmarks the crew are seeing today, is the first time that humans have ever laid eyes on those portions of the moon. In the targeting package, there are a few reminders of the crew. For the crew, there are time-sensitive observation reminders and science sit rep reminders.
Integrity. We have a sit rep. The targets that are being discussed right now, it's the far side, near side comparison, and hearing some great discussion of browns and greens in the Aristarchus Plateau and how those disappear as you go toward the North Pole, and then over to the far side, you lose the color. You've got Jeremy in window 2, Reed in window 1, having a great discussion. Christina's under window, I'm sorry, Reed is in window 3. Christina's under window 1, documenting the discussion. And we've got the lights completely off in the cabin. There are some LEDs that we cannot put out that do provide some light scatter. But we have all of the internal lights off. And are letting our eyes adjust as best we can. The window 4 view, you only get about a third of the moon. Tycho is going to go over the horizon soon, and you can see Aristarchus, and then you start to lose the view as you go to the west in Oceanus and Procellarum. So far, the team is on the plan, and the long lens is being put to good use, and recordings are being made, and internal documentation of the configuration and the observations is ongoing. Science, do you have any questions for us at this time?
Integrity Science. Victor, very glad that you provided the first formal science sit rep, as these were indeed your idea. One follow-up question, any relationship between those browns and greens you described? Do you see them blending into one another, and do you see any topography associated with either color?
I don't want to bother the window team. I just heard that, overheard that, and so I'm sorry I don't have that detail yet. I will eavesdrop and see if I can pick that up. I will try to answer that at some point. I also heard a comparison of the albedo in Aristarchus, that crater, the very high albedo spot. You can see it on the near side. There is a feature called, I believe, Burgess alpha, that is equally or maybe higher albedo. I apologize for the gaps. I'm trying to listen and talk at the same time, but I will try to get some more information to correlate those colors from Aristarchus for you.
Understood, Victor, and good call to not bug the window team. Really like the brightness comparisons to Burgess A. Really helpful for the science team. Keep them coming. Thanks.
I also heard a discussion about the albedo of Grimaldi being a 10, and how many of us, when we were a little further away, saw that as the darkest albedo, and that the bigger mare off to the to the east was still dark, but maybe a 7-8. We still think that, but you are seeing color variation, albedo variation inside of Grimaldi as well, and that even on the west side there's still a very dark part of it. but it is still the darkest. It is just not as uniform as it looked when we were farther away. We're starting to differentiate the striations of albedo inside of Grimaldi.
Copy all, Victor, and you read our mind. Superlatives like darkest, biggest are really, really helpful for us, so keep those coming.
As we were just mentioning, the crew is slated to perform these science sit reps. They are prompted to do so by an icon in their lunar targeting plan. That one coming down from NASA astronaut and pilot of Artemis II, Victor Glover. As we discussed, the Capcom is usually the only person in the room speaking with the crew, the capsule communicator. However, today, the science officer, Dr. Kelsey Young, she is the Artemis Science Flight Operations Lead, is speaking with the crew during the flyby to ask any questions that the team may have. To her right is Trevor Graff. He is one of 3 science officers. Those would be Kelsey Young, Trevor Graff, and Angela Garcia, who will also join us later for an interview.
And Houston Integrity Science Integrity was able to get a view out of window 1, which is a beautiful view. I can see the entire moon that they're looking at. We left the T-shirt up there, so I was kind of peeking through the opening in the makeshift shroud there. And once I was able to get 2 eyes on it, what jumped out at me was Vavilov. It's just peeking out of the Terminator. It's clear of the Terminator now, but it just really jumps out because it's still got the low light, the low sun angle. And so where the, Vavilov has that impact over the top of another crater, where the 2 craters intersect on the eastern edge. So on the side closest to Oriental, where the 2 crater rings intersect, the shadow there is the highest peak in the interior of Vavilov, and so you can see that terrain is, there's some real variation in the terrain there, that there's a nice peak where those peaks intersect, where those rings intersect, and we'll get a picture of that.
Love the description, Victor, especially the comparison and relationships you just described about topography. And if it's easier for your observations, do feel free to remove the T-shirt shroud from window 1.
Yeah, absolutely, we will do. Thank you.
Those calls coming from NASA astronaut Victor Glover. As we discussed, the crew is working in pairs at the windows. Right now, taking photos are Commander Reed Wiseman and Mission Specialist Jeremy Hansen. Serving as their support team are pilot Victor Glover and Mission Specialist Christina Cook. You're hearing those calls from Victor Glover, as he is on that support team, and he is tasked with providing the science sit reps, while the two crew photographing and making annotations of the moon are in Windows 2 and 3. Windows 1 and 4 are available for the support crew to fly up to, obviously look at the moon themselves, and provide these science situational reports. The view on your screen is part of the lunar targeting package, and it's something that the crew can reference as they are flying by, but this is an animation. You also heard Glover mention Oriental. Oriental is a major feature that the team is interested in today, and it's known as the Grand Canyon of the Moon. Until this mission, the Oriental Basin had never been seen in sunlight by human eyes. Oriental Basin and its surrounding ejecta could fit within a straight line distance from NASA's Johnson Space Center, where we are at today, to Kennedy Space Center. This a live view in Artemis Mission Control in Houston, Texas, where the teams are monitoring all systems, not just for today's flyby, but on the spacecraft themselves. Again, this is a test flight, our very first flight of humans on the Orion spacecraft. This team has been monitoring the entire time of the mission, as well as we have been live the entirety of the mission, and we will be continuing to do so all the way through splashdown and crew recovery from the Pacific. This is a visualization from ARROW, the Artemis Real-Time Orbit website that you can also access at any time by visiting nasa.gov/trackartemis, showing us that we are now under 10,000 miles from the moon, 9,948 to be specific, and continuing to count down. Again, our closest approach to the moon today should come about 6:02 p.m. Central, 7:02 p.m. Eastern. However, we will be out of contact with the crew at this time as they begin transiting behind the moon. At that time of closest approach, the distance from Orion to the lunar surface will be about 4,070 miles. Of course, these are estimates at this time, and we'll be sure to provide you with the official numbers once that closest approach has been reached. This shot live inside the Orion spacecraft, where our 4 crew members are continuing with their lunar flyby activities. They have just begun those activities really about 20 minutes ago, so we've got several hours of moon view opportunities. This is still a live view inside that capsule. However, you can see just how dark they have turned down the lights. Actually, they've turned them all the way off. There are a few LEDs that they cannot power off, but turning down these lights gives them better views outside of the spacecraft's windows while they photograph the moon. This also prevents any reflections from inside the spacecraft bouncing up on the windows and interfering with their photography. As we were previously discussing, the crew members are serving on teams, the first team being Commander Reed Wiseman and Mission Specialist Jeremy Hansen at the windows photographing what they see. We heard reports earlier that they could see both the moon and the Earth in the same view, and we are looking forward to seeing the moon and the Earth in the same view as well. That Earth set coming up in just a few hours. While Wiseman and Hansen are at the windows photographing, Glover and Cook are serving as support crew. They are able to assist with cameras. They are also providing those situation reports, letting us know how the team is working inside the spacecraft, what they're seeing, and how they're feeling about it. Those first blocks of teams will last about an hour, and the crew members are approaching the halfway point into their first observation block. A reminder, we have 5 of those blocks today. So they're approaching this halfway point during which the crew at the window will switch roles. One will begin taking pictures, and the other will be making annotations on their PCD, that's portable computing device. Both of those crew members at the windows are recording audio of what they see. They are putting on headsets and recording audio into their portable computing devices. Obviously, we are not hearing this right now. This is going to be sent down to the science team, and they will be able to analyze that at a later time. What we are hearing, though, and will continue to hear, are those science sit reps a few times every block. Once this block is complete, about 40 minutes from now, we will have the teams switch. That means pilot Victor Glover and
Science integrity, looking out of window 1. I think I may have misreported earlier saying that it was Tycho going over the horizon. That was Copernicus I was referring to. Apologies. It was Copernicus is what is farthest bounding to the east, and that is now like on the horizon or just past it. And Korolev is now a few degrees from going over the horizon. And then, next it'll be Aristarchus Plateau. And so on the west, we are getting a much better view of the Terminator. Looks like we have about 80% illumination of the moon. And Vavilov and 1 Vavilov diameter to the west is where the Terminator is right now. And so other features are starting to peek out there. The center of the illuminated part of the moon is to the lower part is Oriental, and just around Oriental, a lot of light structure is starting to show up. A lot of high albedo, similar to the feature, I cannot remember, Burgess Alpha and Aristarchus type high albedo in the ring. So when you look at the interior ring and the external ring, it's almost as if the edges are starting to dry up and turn white. If it was something that was wet and got dry, the edges would be the part to dry first. You just kind of outline all the topography in the interior of that wall is like it was dusted with chalk or is starting to dry, or maybe dusted with snow. If this was the Earth, I would say there was snow dumped on some of the ridges on the interior of the rings of Oriental. Also, an interesting part of the discussion that I heard between Reed and Jeremy is that from Glishko to Grimaldi, there are 2 dark features there that look like commas, but in the wrong direction. But there's also a lot of interestingness, just a lot of geometry and squiggles and dots and lines that are starting to stand out as more small features come into view. And there also is a lot of variation in albedo. And some of those, the 2 dark features, for example, have on the southern edge of the larger one, the one that's further to the south, there's a very dark, the 1 albedo, like the southern and western part of Grimaldi. And the one to the north, closer to Glishko, is also that same dark albedo. And then around them, there are some very high albedo spots just to the north of the southern one, and just to the west, the smaller one to the north. Very high albedo, almost approaching the 10, a 9 or a 10, like Aristarchus. and lots of little bright spots are just starting to pop up on in this view. To the north, as you look up at the North Pole, there is a very distinct crater with a lot of a very defined central peak that is also 3 in albedo, and all of that area past it, going to the horizon, gets lighter and lighter, and is very, very high albedo. And I will go look and find the name of that feature if I can look that up. And then to the south, really getting some interesting geography and topography in the South Pole Aiken Basin. And the view of the South Pole is quite amazing. We've got some Terminator there, as well as the limb view, and there is a very distinct crater right at the South Pole. And I'm going to go look up, I don't believe that is Aiken, but I'm going to go look up the name of that one because it's also giving a lot of good topography due to the shadows that I'm seeing. But that's, I was trying to bound the view that I'm seeing for you and got distracted by all of these interesting albedo variations that are popping up in the interior. But that's the view that we see just a Vavilov diameter to the west beyond is where the Terminator is. Just beyond, I think Copernicus is the easternmost feature that we can see. A very nice ringed, very nice structure crater to the north with a great high albedo central uplift to the north, and the south is dotted by a very characteristic crater with a lot of terrain, shadow features, and I will go try to find some landmarks to put names with those. Any questions for the observation team?
Integrity Science, love the descriptions. You're definitely looking odd up there. Appreciate seeing the training being implemented. Especially interested in your descriptions of the dark patches. You compared the comma-looking features to the albedo you see in Grimaldi and notice that you're starting to see those color differences popping out. Any observations you want to make, especially when you get on, the PCD in a little bit, would really help us tease out the differences in those dark Mare deposits. Great description, Victor. Keep them coming.
Absolutely will do, and I know you've got descriptions on both of the window observers right now as well. Keep them coming.
Great evidence of how well trained this crew is by the science team. NASA astronaut and pilot of the Artemis II mission, Victor Glover, calling down a situation report, noting several different features on the moon and such descriptions, even saying that it looks like snow on some of the peaks. Obviously, we do not expect that to be snow, but referencing that as some of the lighting on how it looks to the Artemis II crew from their current position. The team is slated to be switching their positions at the windows now. Both Reed Wiseman and Jeremy Hansen have been at windows 2 and 3, one taking photos, one making observations and annotations on their portable computing device. At this time, we also anticipate that they are looking at a crater duo. One of those is Glushko, and the other is Ohm. The team is looking to know the extent of Glushko's ray system and how its rays differ in the Mare versus the Highlands. They also want the team to compare the ray systems of Glushko to Ohm. Ohm is considered a young crater. And if you've ever seen a photo of the Richat structure, it's also known as the Eye of the Sahara. It's 40 kilometers in diameter, and that could fit within Ohm's interior. The team is specifically interested in descriptions of that ray visibility, including the color, albedo. Remember, albedo is the brightness or the surface reflection, and the reach. Again, I am using the same lunar targeting package that the crew is referencing on board right now. This helps keep them on time as well as prompt them for when they need to make a call down to the science team and report what they're saying. It also gives them reminders of when they need to swap positions at the windows. Additionally, I'm using the Artemis II Lunar Science Passport developed by Amber Turner and the Artemis II Lunar Science team. Now, this passport did not fly with the crew, but they used it extensively as a study guide here on Earth. So a lot of the descriptions and comparisons you hear today are developed directly by the science team. We are now 4 days, 20 hours, and 43 minutes.
Science, integrity, that crater to the north, that is, it's like we've got one in the north that looks like just a textbook crater, and one on the South Pole as well. The one on the north, I think, is Pythagoras. And what I wanted to highlight about that is it is either a very distinct central uplift or just a very defined area of high albedo. If a majority of the crater, especially the floor of the crater, is, say, an albedo of 5, this center, and gosh, only a tenth of the diameter of Pythagoras is an albedo of 2, maybe 3, but it is very bright and it stands out. And then between that crater and the actual, what is the horizon from here, there seems to be another crater right on the horizon, and right on the edge of that is another patch of that albedo. It seems to be between the two craters. It's hard to tell from this grazing angle, but there is another spot just further north beyond Pythagoras. Between the two, I can draw a picture of this one and show you where that very high albedo, again, another 2 albedo surrounded by 5 and most of the area bounding it.
Integrity Science, thanks for that. We agree with the Pythagoras assessment. And as a follow-up to your previous report, the SIR had questions about topography comparisons between the North Pole and the South Pole of the Moon, if you're willing to provide words on that.
Topography comparisons, absolutely. And if you have any idea what... if you draw a line between Pythagoras and the western edge of the outer defined ring of Oriental, it intersects a beautiful textbook crater on the south. I would love to know the name of that. The topography differences, now the South Pole has a little bit of a benefit that it has more of the terminator, and I can see a little more shadowing there, but there's a nice crater right at the South Pole, so that's the main thing defining the topography there. Seems to be quite a bit of elevation change. I can see some very jagged shadows, a 90-degree just to the west of that crater at the South Pole. I can see a very distinct change in the shadow directions, indicating, I don't know, a very high wall or a very deep canyon just to the west of that. And in the north, it seems to be that from sort of the edge of the mare that's dark, which is maybe 1 Pythagoras diameter south. If you draw a ring about that, maybe the top 7 degrees of the moon, and just draw a ring around that, the near side is an albedo of 5 and looks quite smooth from here. And then along the same edge of the mare, the edge of the mare that kind of Grimaldi's just outside of, Glushko is just outside of, Carroll Crater is just outside of, and you start to see the stark differences between the darker 7/8s and the 5s and 6s, the 4s and 5s. If you follow that line up to the north, that line is also where the change in topography happens at the North Pole. The line defining the light and dark on the edge of the mare that you can see from Earth. Draw that line, roughly the midpoint of all that, straight to the North Pole. And on the side facing the Earth, you see smoother topography and dotted by Pythagoras and its next door neighbor crater. And then on the far side, you see a lot more cratering and a lot more topography. And again, the far side has the benefit of a little terminator there, but I am seeing a variation in the topography. It seems to be more jagged and a more challenging place to find a place to land and to even traverse in the south, all around the South Pole. And at the North Pole, it seems to be, it would be more challenging to translate on the far side of the North Pole compared to the near side of the North Pole around Pythagoras.
Copy all, Victor. You really help paint a contextual picture of what you're looking at. We really appreciate the way that you're guiding us into the areas you're seeing by drawing comparisons between recognizable features. Thanks for that.
And Kelsey, another little science sit-rep moment, something I just heard from the window team is the more I look at the moon, the browner and browner it looks. I thought that was an interesting observation. The 2 observers have been on timeline, no hardware issues. They did start to talk a little bit about another feature that you'll hear more about on the recordings that they call the handprint. That was at the end of their Glushko and before they moved into their current target. They thought that was worth chatting a little bit more about. And they're preparing to switch after this.
Houston copies and concurs.
Hey, Houston and Science Integrity, another just observation from the human. My eyes have shifted a little bit since I've been up here. I've been wearing my reading glasses to look at the PCD. Well, this is a very taxing event on the eyes, looking out the window and seeing the very bright moon, then coming back inside to the dark cabin and trying to work cameras and microphones and logistics and lunch and those kinds of things, and then looking at the PCD, which is dimly lit. It's just been an exercise. It is a difficult thing to manage it. I'm up and down on the glasses and then having to wait as my eyes adjust when I come back in. As soon as I look back into the cabin from looking out the window, I can feel my eyes adjusting, and I just have to work through it as they adjust.
Appreciate that report, Victor, and know that we are prepared to read you up targets from the ground if that would give you the ability to keep your eyes focused on the moon and not having to swap between that and the PCD. Just let us know.
Yeah, we appreciate that, Science, and we will also do that for the window teams, and we'll back each other up that way as well. But we appreciate that. We may take you up on that. Thanks.
Continued detailed descriptions from the Artemis II crew aboard Orion. Again, this is a test flight, the first time we've flown humans aboard this spacecraft. So every detail, even that it's difficult to look outside the window and then back at the PCD, that portable computing device, every single detail is appreciated as we prepare for future missions. Glover also mentioned that he is now wearing his glasses now that he's in space and that his eyes have shifted a bit. This is something that happens when our astronauts go to space. There is a fluid shift from the lower half of your body up into your head, and that can cause changes in your eyes. It's something that we have seen over time for some crew members, especially now that we have been living and working on the International Space Station for over 25 years. Again, it's clear that these Artemis II astronauts have undergone extensive lunar science training, including classroom instruction, fieldwork, and high-fidelity simulations. Training expeditions even took place in analog environments like the Icelandic Highlands and the Kemasassen impact crater in Labrador, where crews practiced identifying and describing geologic features under varying conditions. Additionally, here at Johnson Space Center, Orion mock-ups were used to rehearse crew choreography, including three-dimensional space management with an inflatable moon globe to simulate the flyby. And while on Earth, the crew also used that small lunar passport that I mentioned with descriptions, photos, and prompts to help them study the features we hope they'll see. Now, this is a view from their lunar targeting package at this time, helping them determine what they're seeing on the moon, as well as on the left, keep up with what their next target will be. As you can see, we have got a long list and an exciting day ahead of us. It's now been 4 days, 20 hours, and 53 minutes since Orion launched atop the Space Launch System rocket from Kennedy Space Center in Florida with our 4 crew members aboard. NASA astronauts Reed Wiseman, Victor Glover, and Christina Cook, and Canadian Space Agency astronaut Jeremy Hansen. The Artemis II crew passed a major milestone today when they passed the Apollo 13 distance record at 12:57 p.m. Central, 1:57 p.m. Eastern. That Apollo 13 distance record was 248,655 statute miles from Earth.
And Houston, another observation, whole moon. When you look at the moon, something I've never seen in photographs before, but is very apparent, all the really bright new craters. Some of them are super tiny. Most of them are pretty small. There's a couple that really stand out, obviously. And what it really looks like is like a lampshade with tiny pinprick holes and the light shining through. They are so bright compared to the rest of the moon.
We copy, Christina. Thank you. Looks like you guys might be doing it, but remind you to swap positions at the window and take your SD cards with you. We're loving everything that you're calling down, so keep it up.
Again, Orion previously surpassed that the Apollo 13 greatest distance from Earth by humans. That was 248,655 statute miles from Earth, and Orion now 250,294 miles away from our home planet. The spacecraft is 9,033 miles away from the moon and growing ever closer. At its closest approach, it'll be about 4,070 miles away, and we will make sure we confirm what that distance ends up being. This is an approximation and an estimate ahead of that moment. We're anticipating them to make that closest approach at 6:02 p.m. Central, 7:02 Eastern, when they are in a loss of signal, transiting behind the moon. They will be the first humans in over 50 years to fly behind the moon and lose contact with Earth. We will regain that contact about 40 minutes later as they reconnect to the Deep Space Network, emerging from behind the moon, and we will look forward to seeing an Earthrise. Again, the crew is currently in their position swap portion on their timeline. This allows crew members the opportunity and the experience of all roles necessary during today's flyby. Right now, those two crew members at the window have swap positions. Again, the crew at the windows swapping positions. Right now, that crew is Commander Reed Wiseman and Mission Specialist Jeremy Hansen, while Victor Glover and Christina Cook serve as their support flyby crew members. That's why you are hearing Victor and Christina during those science situation reports. Those voices will change in about 30 minutes when they take a turn, taking photos and making annotations while at the window.
Houston integrity. I wanted to provide an observation or a little bit of descriptive nature on something that we saw on the first day we had good moon views. This was when we saw more of the near side, and the ground helped me out with identifying Mare Imbrium. Mare Imbrium, when you have the western limb also in view, looks completely different than the normal view we have of the near side. It is the most striking feature of the western limb view that we had. And the mountain chains that form its eastern side are very prominent, but they actually stand out more than I'm used to seeing even on the western side, and the whole thing just feels like a big bump. It actually looks like a large healing wound with a high albedo forming the mountain chain around the impact basin. And I just don't think I had enough chance to describe how striking it was on that western limb view as we were coming in a couple days ago.
Christina, science, absolutely love that, especially since that's a feature that all of us here on Earth can observe from home. So I'm sure tonight everyone's going to be going out and looking for evidence of that beautiful topography you just said. Thanks for those words.
The view on your screen coming from Orion, a camera mounted on the spacecraft's solar array wing. Toward the right of your screen, the near side is the hemisphere we see from Earth. That is identifiable by those dark splotches, which are ancient lava flows.
Science integrity. A question and a comment. Question, is it possible that we're seeing a Schrodinger basin from this vantage point in the Terminator at the South Pole? And the comment is Ohm. The rays coming out of Ohm are less distinct. We are not seeing the bright rays coming out of it, but the sort of 9 o'clock wedge that is formed by the change in albedo from the interior portion that is to the northeast to the surrounding lighter mare that's 270 degrees to the west. That 90 is very distinct and interior. You got some great descriptions from the two at the window about the colors in there, but in that darker part, in that wedge, you've got some really interesting color, even though the rays, the distinct difference in the albedo almost look like rays, but it's not the rays coming out, it's the just change in that albedo.
Integrity Science, that is very intriguing, those color rays coming out of Ohm rather than sort of albedo. And as answer to your question, we do not think you can see Schrodinger. It's in darkness as of now. But thanks for that Ohm description, and it sounds like the pair at the window's got great descriptions that we're definitely going to dive into tonight.
Okay. If you could help me, I would still love to know what it is. There's a very nice crater. You're going to likely have a lot of pictures of it. What would be right in the Terminator at the South Pole or close to the South Pole where it's intersecting the Terminator right now?
Yeah, Victor, we're assuming you're talking about, kind of if you're looking at the Terminator, it's basically like 70% down from the North Pole. Is that where you're looking?
Contact, yes, that is where I'm looking.
Integrity Houston, that is an enabled caution for wastewater dump required. We have hit our limit. As expected, no crew action.
Copy, no crew action.
You are.
And Integrity Science, we're trying to figure out what you're looking at there. Is it like right on the Terminator, or is it in the eliminated portion next to the Terminator?
While we wait for a response from the crew, the Terminator is that difference between day and night, or brightness and darkness, that you see on the moon. We see this from the International Space Station as well, looking down at Earth.
And Science from Integrity, excuse my space orientation adaptation. If you draw a line between Glushko through the center of Oriental, and then another line from Glushko through the southern tangent of Oriental, that line would almost perfectly intersect tangentially the crater that I'm talking about, and it is on the Terminator. So yeah, I think I'm not looking at the South Pole. I was a little twisted.
That line description was really helpful. I have eyes on the SIR right now, and they are actively discussing lunar geography. We will be back with you shortly.
You're hearing a couple of voices today in Mission Control Houston. One of those is Dr. Kelsey Young.
Integrity Science, we believe that's Zeeman Crater.
Oh, I floated away from the speaker. Say it again, please.
We believe that that is Zeeman Crater.
Zeeman. Okay, and can you say the first letter? I may be pronouncing that wrong. What's the first letter of that word?
Zulu. It's Z-E-E-M-A-N.
Copy. Thank you for that. Yes, we've got a great view of that. And when I went back to the window just now, the view has completely changed. Our trajectory is taking us to a new view, and I'm looking more into Babalov. I've got a nice, great view into Babalov. I'm actually away from the window right now, so I'm going to go try to give you some bounding words on the view that we're seeing. But I've got to get back to a window in a minute.
Understood, Victor. You're defining new views of the moon in more ways than one.
Again, when you hear calls down to science or from science, that's Dr. Kelsey Young, the Artemis Science Flight Operations Lead here at a console in Mission Control. You also hear communications with the crew from Canadian Space Agency astronaut Jenny Gibbons. She is the Capcom for today. She is a backup Artemis II crew member. Those calls from pilot Victor Glover asking about a feature he was seeing, specifically a crater on the moon. Meanwhile, the team here in the science evaluation room was actively working together to determine what feature he was describing. The teams at the window have continued to move through their targets, including Ohm, Aristarchus Plateau, Reiner Gamma, and we are preparing for the cabin and window teams to swap. That's when we'll hear more from Reed Wiseman and Jeremy Hansen when they take on these support roles, while Christina Cook and Victor Glover are at the windows photographing and annotating. As we briefly mentioned, if you look towards the right side of the moon, essentially, this live view coming from a camera outside the Orion spacecraft, and if you look on the right side of the moon where you see those dark patches.
Wow, yeah, I wish I had some more time to just sit here and describe what I'm seeing, but the Terminator right now is just fantastic. It is the most rugged that I've seen it. From a lighting perspective, there are little islands. There are islands of terrain out there that are completely surrounded by darkness, which indicates some real variation in terrain. Up to the north, there is a very nice double crater. It looks like a snowman sitting there, in the 5-10 degrees below the pole in the Terminator. And then on the southern edge, there's almost like a hole. It looks like a hole, and it's the diameter of Vavilov size, just blackness, and then a wall of bright, and then it goes back to the black beyond the Terminator. So there's it looks like there's just a gigantic hole right there, 1 Vavilov diameter east of the Terminator. And as you go south, the Terminator is not a nice smooth arc. It's just jagged. There's almost a 110-degree turn in the shadow as opposed to the nice smooth arc, again indicating some really interesting variations. And I'm sure we'll get some photos of that. And then one of the craters further to the south of Vavilov, maybe halfway down to the South Pole, is not only looks like just a deep hole, and then there's like 2 island rays pointing off to the west and north that indicate very high ridges and very deep canyons coming up out of that crater. So again, There look to be islands out beyond the terminator because some of the things, maybe even a Vavilov diameter into the terminator are catching sunlight on the peaks up to the north and to the south. It's very, very interesting to see.
Integrity science, oh my gosh, that was an amazing picture you just painted. I glanced over at the SIR video and I literally saw fist pumps in the air. Those types of observations are things that humans are uniquely able to contribute, and you just really brought us along with you, so thanks for that.
That's awesome, Kelsey. Did you get a sit rep updating you on a slight change in logistics for PCD use?
Christina, this is Houston. We did not, but we will take it now.
We slightly changed the PCD plan for the window observers. The two window observers kept their PCD. So in other words, the one at window 2 went to window 3, and the one at window 3 went to window 2 when they swapped rather than staying at the window. We'll plan on all observers keeping the same PCD for all observations.
Copy, Christina. That makes sense to us, and good plan. We are coming up here on a cabin and window team swap. Let me know when you're ready for a quick vehicle status.
As you heard, science.
Houston, go for the vehicle system update.
Howdy, Reed. We don't have much for you. We just wanted to let you know that toilet right now is no-go for use as we stick with the predetermined limit for now. All crew members, please use CCUs. Otherwise, Orion is looking very good. And you have 15 minutes in this handover time where we expect Victor and Christina to switch to the windows and you and Jeremy to be in the cabin assisting. Let us know if you have any questions.
No questions at all, and they're in the swap right now. The first thing I'll tell you, I floated up to the docking hatch window and just what I'm going to call the Mari around Oriental just looks so different out the docking hatch right now. It's quite a bit darker. It's the same darkness, if not a little darker than Grimaldi, but it's cool after just being in the 400 mil for the last half hour, looking up close. I got pictures of everything Ike was just describing on the Terminator. It really is a fascinating Terminator, and then Oriental just looks so dynamic right now. It's very three-dimensional out the docking hatch compared to what I was just looking at through the 400 mil.
We love it. We are getting a sneak preview from one of our SAW cameras at what you're looking at, and we see some of what you're describing. We cannot wait to see your photos. Thanks.
Yeah, Jenny, I wish you had some longer lenses on the solar array so you could see the whole moon, but man, it is, or the up-close moon, not the whole moon, but it is just fascinating here. It's so cool.
All right, MPO and Inco, take notes. We want a zoom lens on those saws next time. Thanks, Reed.
Affirmative.
As the crew gets ready to switch positions from the window crew going back to the support crew and the support crew flying up to the windows. This view inside the room, Capcom Jenny Gibbons speaking with the crew, Canadian Space Agency astronaut. The crew has continued to provide excellent descriptions of what they are seeing on the lunar surface. In this picture, or in this live view actually, from Orion and a camera mounted on its solar array wing, if you look at the dark portion on the right side of the screen, those are visible from Earth. That's considered the near side. Those are ancient lava flows from a time early in the moon's history when it was volcanically active. And if you look towards the left, there's that dark, large crater that appears to the left of those lava flows. That's Oriental Basin. It's about 600 miles wide, and it straddles the moon's near and far side. And this mission is the first time that humans have ever been able to see this with their eyes in the daylight. Again, you hear conversation about that terminator. You have a great view of that as well. That's the difference between light and darkness on the moon. Victor Glover explaining that as a very jagged looking terminator due to the peaks that they're seeing and the craters that they're seeing as they prepare to cross over the far side. You also heard science officer, the Dr. Kelsey Young, Artemis Science Flight Operations lead, sharing with Victor Glover that his responses are truly something that only human eyes can discern or provide. So we've previously discussed how having humans observing the moon on this mission is being combined with lunar robotic data to help us maximize what we know about the moon. So part of that data comes from the Lunar Reconnaissance Orbiter, or LRO. This orbiter provides the robotic foundation that makes Artemis 2 lunar science possible. LRO has been orbiting the moon for 17 years, which makes it the longest operated lunar orbiter in history. And it's also the only American spacecraft dedicated specifically to lunar science and exploration. Artemis 2 lunar observations are designed to complement data like the detailed surface images from LRO. So while LRO provides those detailed high-resolution maps of the moon's surface, the Artemis 2 crew adds human observations that focus on regional context and relationships between features, giving scientists a larger geologic picture. Now, this combination of robotic and human observations strengthens lunar science. LRO delivers precise and repeatable measurements over long periods of time, while the Artemis 2 crew contributes real-time visual descriptions and context that robotic instruments alone cannot provide. The best description I've heard while preparing for this mission is to compare the difference in looking at the moon with your own eyes on Earth and trying to take a picture with a camera. The camera truly never does it justice, and it's much easier to describe and perceive what you're seeing with your own eyes than to take a photo. These Artemis 2 astronauts can rapidly scan wide areas and adjust their focus in real time, as well as describe relationships between features. The crew will also observe the same regions multiple times under changing lighting conditions during the flyby and provide perspectives that would take robotic missions years to accumulate. During the Artemis 2 mission, LRO is also attempting to observe some of the same lunar features that the astronauts are studying. Collecting this data simultaneously highlights how different instruments and human eyes provide complementary information about the moon. This LRO data plays a direct role in preparing for future Artemis missions. Its measurements of topography, surface temperature, composition, radiation, and lighting conditions are used to assess hazards, identify safe landing sites, and locate potential resources such as water ice near the lunar South Pole. This mission, Artemis 2, represents the point where years of robotic preparation are paired with human exploration for the first time in the Artemis era. So together, LRO, the Lunar Reconnaissance Orbiter, and Artemis 2 are demonstrating how NASA moves from mapping the moon robotically to exploring it with humans. We are laying the groundwork for future Artemis missions and sustained lunar operations. A check-in with Orion. We are now 4 days, 21 hours, and 22 minutes into the flight of Artemis 2, our crew aboard the Orion spacecraft. We are now 8,153 miles away from the moon, 250,742 miles away from Earth. The spacecraft is traveling at 1,030 miles per hour.
All right, Houston, the professional science update giver is now in seat 2. That is where Victor is, and Christina is nestling into seat 1 with the long lens, and we're just getting ourselves oriented here. It's a cool view in the cabin. It's actually a cool view to be off the camera now and looking at my crewmates getting up to their observation post and looking in. It's super fun.
Copy all, Reed. We like it.
As we heard confirmation from NASA astronaut and commander of Artemis 2, Reed Wiseman, they are now switching positions of the support teams and the observation teams. So initially, Reed Wiseman and Jeremy Hansen were at windows 2 and 3 in the Orion spacecraft, taking photos and making annotations in their PCDs, portable computing devices. They were also giving audible descriptions into their PCDs, wearing headsets with microphones and providing recordings that the science team will be able to listen to later. We were hearing from NASA astronauts Christina Cook and Victor Glover as they made observations as part of the support team. Now, as these teams are swapping, we anticipate hearing more from Reed and Jeremy as they'll be on the support team, while Victor and Christina will be at the windows taking photos and making annotations.
for the science team if they can mark this time. I just covered up window 4 to block out the ambient light from a very bright planet Earth. And it'll be interesting to see if in the data Victor and Christina see any differences from me and Jeremy with that window blocked. It's a lot darker in the cabin now.
Copy, Reed. We're taking note. We'd be curious too.
We are live in the Artemis mission control room during the lunar flyby of the Artemis II crew, the first humans to fly by the moon in over 50 years. Orion launched 4 days, 21 hours, and 30 minutes ago atop the SLS rocket, Space Launch System rocket from Kennedy Space Center in Florida. Our 4 crew members inside the spacecraft are transitioning their positions. The cabin and window teams have swapped. Currently at the window, we have Victor Glover and Christina Cook, NASA astronauts, and serving as support, Reed Wiseman and Jeremy Hansen. For our crews at the window, they are using handheld Nikons with an 80 to 400 millimeter zoom lens. There are also GoPros on each of the solar arrays on Orion, and that's where this view is coming from right now. We have an interior camera of the crew as well, but they have dimmed the cabin lights. They've actually turned off the cabin lights to allow them to better see outside of the spacecraft. This also helps prevent any reflections from lights inside the spacecraft reflecting onto the windows while they are photographing the moon. We talked a little bit about the views and the cameras being used on the Orion spacecraft. And again, we do have GoPros on the tip of each solar array wing. Now, the bandwidth is a little bit limited because having a crew on board, we do have to downlink a lot more data. That includes their environmental control and life support system. We are not the only data, this view that you see, coming down from the spacecraft, and so we do rely on sharing some of that with the other flight controllers in mission control. This helps the team monitor all systems aboard the spacecraft and ensure the safety of our astronauts.
Travail di chaque jour sans prendre souffle. Apprendre l'ité, li pas jamais découragé. Sorti sous terre.
We are standing by for a situation report from the crew aboard the spacecraft. They've been imaging the whole moon. There is now a new crew at the window. That would be Victor Glover and Christina Cook. And so being it's their first time since they have moved up to the window positions, they have a chance to orient themselves and describe and take pictures of any color or albedo variations across the surface. Reminder, albedo is the brightness or reflectiveness.
Integrity science for a science sit rep when you're ready.
Houston Integrity, we have no external view of the moon right now for the floating crew members, so my only science sit rep is that we have Victor in window 3 doing observations and Christina in window 2 with the long lens.
Integrity, we copy. Are the shrouds still on windows 1 and 4? And if so, would you consider trying to get a view through one of those windows?
We cannot take the shroud off of 4 because the Earth is too bright and it's impacting Ike's peripheral vision. And then I can get a grazing glimpse out the docking hatch window. I can see Oriental south down to the South Pole. And the primary thing that I see from Oriental right now is just the long trenches that come out. And, you know, when you come out the north side of Oriental, the ejecta kind of boulders across the northern half of the far side. But coming out the southern half of Oriental, I just see those large, here they look like gorges. They're almost like rain when it comes down the Grand Canyon and fingers off into the desert, kind of what it looks like. Also, Burgess Alpha is extremely bright. It's the brightest thing that I can see. Even brighter now than Aristarchus, which is heading off to the Terminator. It's almost impossible now to see Aristarchus, the thing that Jeremy and I looked so much at. I can just barely see the crater rays from Ohm, and I would say for albedo right now, I would go back to Grimaldi is still extremely dark, especially in that southwest corner, and there are parts of Oriental and the outer ring of Oriental that reach that same level of darkness, especially the rings of Oriental reach the same level of darkness as Grimaldi. And then south of Grimaldi, Jeremy and I were noting a few other just really dark areas of cratering, mare there, and those have that same darker albedo. But
to give us that description. Any comments before you go on the annular ring in Oriental?
The annular ring, which I think everybody kind of describes as like a pair of lips or a kiss on the far side of the moon from here, is very circular in nature. The northern part of it is wider, darker. The southern part is much lighter. It is very neat looking, and but it is far more circular than I remember it looking in our training. The darkness of the northern side of the annular ring is the same darkness from here out this docking hatch window as the center mare in Oriental. Not quite as dark as Grimaldi, but it is probably only because dust and lunar regolith has kind of impacted over time.
Reed, that's exactly what we were looking for. Thanks so much. You have heart hands coming out of the SIR.
Say that again, Kelsey.
Just saying that the SIR was really excited about that. That annular ring was something we were really eager to hear about, so thanks.
Yep, you bet. And now Victor and Christina are moving on to Oriental. I got them situated over there a little bit late.
At a later time. They will then review it and compile all of this data to help further our understanding of the moon. One of the items you heard mentioned was Oriental Basin. This has been a very exciting opportunity for the crew. They have all been very excited about seeing Oriental, as well as the science team has been looking forward to it. It is known as the Grand Canyon of the Moon, as we discussed earlier. From the pictures, the science team is hoping that the crew will take centered images of the entire basin and surrounding craters in a single frame, but also use those 80 to 400 millimeter zoom lenses to create a mosaic entire basin. With their unaided eyes, the science team is hoping the crew will describe southern dark annular ring, which you heard Reed just describing, as well as any color, albedo, texture, or topography across the mare patches and ring mountains. Science team reports that the observations will be used to study the geologic evolution of the youngest lunar basin and to inform formation hypotheses for the annular ring. And again, another fun fact about Oriental is the diameter is the same distance between Johnson Space Center, where we are today, and Kennedy Space Center, where the crew launched on April 1st. This live view from the Orion spacecraft on the Artemis II mission, now 7,373 miles away from the moon, 251,130 miles from Earth.
Étoiles yo t'a brûlé li en haut là. Oh. Yon rêve nan quel li pas jamais mourir. Li dit m'a volé plus loin passé noir joui. Li te travail dit chaque jour sans prendre souffle. Apprendre li te li pas jamais découragé. Sorti sous terre arrivé dans ciel bleu. Bon Dieu l'ouvrit chemin pour lui marcher. Même l'aile difficile. Quelle belle la foi. Papa, j'aime la guerre vous. Papa, bataille. Rive jouk dans la ligne. Pas de limite encore. Victor Glover montre nous qui j'en pour monter. Mes premiers pilotes noirs. Histoire avec lui. Avec courage dans quel lit.
PCD, or the portable computing device, to conduct annotations. They are both recording information that will be downlinked to the science crew. And tomorrow morning, the science team will have a conference with the team while the information is so fresh. They'll be speaking with the crew about their observations and their data collection. Otherwise, most of tomorrow, Flight Day 7, is considered an off day.
Tout moun sou terre Vive jouk nan la ligne Pa gen limite ankor Victor Glover montre nou ki jan pou n'monte pi haut Premier pilote noir Histoire pétrie Avec courage nan Kelly li di an ale Nan mission Artemis Li prend direction Allant tout la ligne li pote lumière
A few times every hour, they are slated to call down with science sit reps or situation reports. We most recently had one from Commander Reed Wiseman. He and Jeremy Hansen, mission specialist, were first at the windows today to photograph and make annotations of what they were seeing. Therefore, we heard more from Victor Glover and Christina Cook earlier in the day during those first blocks. But now that Reed Wiseman and Jeremy Hansen are on the support side, they are the ones calling down what they are seeing from windows 1 and 4. Earlier, we heard that the Earth is so bright in window 4, they have had to temporarily cover it with a t-shirt. The moon preserves a near-continuous record of solar system history that has been erased on Earth because the moon doesn't have an atmosphere. So things that we experience on Earth, like weather or plate tectonics, don't really apply. So the lunar surface retains evidence of ancient impacts, volcanism, and solar activity that scientists can study today. And studying the moon helps scientists understand how planets formed and evolved, how the moon influenced our own planet Earth's history, and how the sun shaped conditions across the inner solar system. The moon also serves as a unique platform for studying the broader universe. Artemis science is designed around questions best answered by humans, working alongside robotic systems, combining decades of robotic lunar data with real-time judgment, context, and adaptability that only humans can provide. This mission, Artemis 2, is serving as a proving ground for lunar science operations, which allows NASA to test how science is planned, executed, and supported during a crewed deep space mission ahead of our future Artemis flights.
Integrity, time for a window team position swap. So Victor and Christina, please switch places if you've not done so already, and remember your SD card for the camera.
We're in the swap right now. They're wrapping up their last comments, and they'll switch over and change cards in the long lens.
Copy.
As you heard in that call, it is now time for the team members at the window to swap positions. That means Victor Glover and Christina Cook will be switching roles. One of them has been photographing the moon with a Nikon with an 80 to 400 millimeter zoom lens, while the other was making annotations on their portable computing device. And both are recording audio that the science team will be able to listen to. We are now 2 hours and 10 minutes until we expect to lose signal with the spacecraft as they fly behind the moon. And the next target for the crew is considered a crew choice event. They have the option to focus on any regions or patterns or features that interest them. The science team has asked the crew to capture pictures that illustrate their choice, as well as at different zoom levels, and to describe why those certain features or regions caught their eye. Those recordings are part of what are being saved on their PCDs, portable computing device, that will be sent to the science team for analysis. The crew has been allotted 8 minutes for this crew choice event, and it's also a time for a scheduled sit rep or situation report. So we expect to hear them calling down what they are seeing soon. Something that the crew or that the science team has used to help prepare the crew is a cue card. These ask for a feature ID if they happen to know the type or name, and if it is a target. Of course, in this situation, when they have a crew choice, they do not need to, it may or may not be a target. They want to know the location and the observation style. They've also asked for the geometry of what's being captured, the size, shape, boundary, and preservation, as well as the color and shadow. So the color tone, the albedo, that reflection or brightness, and any shadows or illumination. Next, they're interested in structure and texture. That includes slopes, structures, and textures, of course, and geologic relations, like association to other features, any contact to those features, and of course, their thoughts, impressions, or interpretations. They are interested even in emotions and excitement that the crew may be having. This flyby day has been practiced in many ways, even in sims here in Mission Control Houston. The team also conducted some field work, learning how to look for specific geologic features. They also photographed a large globe, and the science team helped them determine which features they would be targeting and how to look at those. We have a few more minutes that the crew would be photographing their crew choice. Again, this is NASA astronauts Victor Glover and Christina Cook at the windows. They will then move on to another discussion portion. This is for the far side albedo, that reflectiveness, and color that they are seeing. We heard earlier about some browns seen on the moon, which is very interesting, especially here from Earth, where we are just seeing whites, grays, and maybe even black at some points. When they get into that discussion for far side albedo in a few minutes, the theme is looking to know how that color and albedo is, what those variations look like across the far side. On the right side of your screen, the Science Evaluation Room, or SIR, where team members are looking real time at what the crew is seeing. And even earlier, we're...
Houston Integrity, you ready for science zero?
We'll take it.
Okay, the crew has swapped positions. They're in their crew choice element. I've been listening to both of them for a little bit, and they're really enjoying, they both decided to pick the Terminator, and they're spending a lot of time looking at the Terminator, just talking about the resolution that they can see, the depth of the craters, and the various interesting and unique excavations that they can see. So Victor is on the long lens, and Christina is just looking out the window, and I'm sneaking a peek in T-shirt window. It looks like, I don't have the best angle here, but it looks like Aristarchus is on the limb of the moon now. It's amazing how quickly it changes as we speed around the far side of the moon, stuff that's leaving our field of view, and now we have a lot of the dark side of the moon that, you know, it's missing for us right now, but it would be in view if it was lit at all.
Jeremy, Science, thanks for that sit rep. Do have a question. A few times we've heard you and the other crew describe change during the course of your flyby. Would be interested in future descriptions of more verbosity about how it's changing. Thanks for the great sit rep.
Yeah, Kelsey, sounds good. We are definitely keeping an eye on that. My eyes have just not readjusted. The moon is so bright when you come back to the window. I was just in the interior of the cabin. I've come back to T-shirt window, and it's just overwhelming brightness, and my viewing angle is a bit challenging, so I won't be able to give you great observations from this window. But I will talk about something that I was talking a lot about in my recordings earlier, which was we've been talking about some shades, and so we have obviously the dark and the light gray, and then we've talked about naming some colors, a brownish hue and a greenish hue. And I'll tell you, like right now, Aristarchus, the plateau is hard for me to see from this window, but that had greenish hues to me and was very unique. I didn't see anything like that anywhere else on this side of the moon. And then I see a lot of these, what I would call brownish hue areas. There's a number of them. And they, for example, in the northwest corner of the highlands, to me it looks like the brownish hue is caused by ray or ejected material landing on the highlands, and then we obviously see the ray areas as a lighter albedo, but in between the rays where the the deposit would be thinnest, that is what it looks like is causing the brown to me. So I saw that on the northwest side of Aristarchus, or sorry, that dark area of the highlands, northwest side of the highlands. I saw it in the highlands to the east of Glushko. And then I see those same brownish hues west of Oriental. And I drew a contact there on OneNote, but that's a huge region, kind of like a piece of pie with the point of the pie pointing at Oriental and then going up towards the northern side of Hertzsprung. And that is an area that just looks like that brownish albedo.
That was fantastic, Jeremy. We had heard rumors of the green and brown hues, and so you really read my mind on asking about those. Understand they likely didn't have any contact with each other the way that you described them, but please correct me if I misunderstood that. And then last thing, I'll make the same offer we made to Victor earlier. If it would be helpful for us to verbalize any targets so you can stay at the windows and keep your eyes adjusted to the moon, please let us know.
If you got something you want us to look at, Kelsey, you can send it on up.
Definitely not looking to interrupt your flow, Reed and Jeremy, only offering assistance if you guys want to keep your eyes off of the PCDs.
Oh, I see what you're saying, okay. Not really science related, and we definitely learned this at Apollo, but the thing that is just most fascinating, I think, to me and Victor right now is even as rugged as the far side looks, when you look at Oriental and Ohm, it's rugged, but man, when you look at the Terminator, it is just like impossibly rugged, and it reminds you that the whole far side is that way, and just the Terminator is really bringing out the shadows and the hills and the valleys, and it's unbelievable. It's like no surface of the Terminator is not marked by meteor impact, and it is very impressive to look at that, and you realize that is true across the whole far side. You just can't see it due to sun illumination right now.
Reed, Houston copies, and we were commenting on the same thing. Even from our view, the Terminator looks absolutely alien because there's just so much texture in there that we're just not used to seeing. So thanks for sharing that with us.
There's also, I don't know the name of it, coming out the south-southwest of Oriental, right on the southern Terminator, is just a massive crater. I don't know the name of it. Maybe you can look on the solar array wing video and tell me it's right. It's the southernmost crater you see on the Terminator right now.
We're looking for you. We're loving that picture. Thanks for showing us. And Reed, as an answer to your last question, we believe that that is Chebyshev crater. And the sir agrees with that.
Okay, that picture I was just showing you is an 8X iPhone out the docking hatch for the high grazing angle. It's just amazing.
We love it. Thank you.
This is Artemis Mission Control in Houston, Texas. Mission elapsed time, 4 days, 22 hours, 12 minutes into the flight of Orion. This is Lunar Flyby Day for the crew aboard the spacecraft. Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen are now the farthest people to have ever traveled from Earth. This a live view from inside the spacecraft. They have turned off the lights so they're able to see outside and photograph the moon better with no reflections from inside. And for a very brief moment there.
Integrity Science, thanks for those iPhone views. It's helpful to see what you're seeing.
We very briefly saw NASA astronaut Reed Wiseman showing a picture he took on his phone of the moon. We do expect to get all of the photos that the crew is taking today, and we cannot wait to share some of those with you. But pretty cool in the meantime, just to see one quick shot from what the crew is seeing. And this view from outside the spacecraft on Orion's solar array wing. Orion is now 6,643 miles away from the moon and continuing to grow closer. Again, their closest approach will be about 4,066 miles. The best comparison is if you held a basketball at arm's length. That's about what it would look like to the Artemis II crew at their closest approach. This view showing at the very top, a camera coming from Orion, continuing their flyby of the moon. We have 3 more flyby observation blocks after the completion of this one. Down in the bottom left of your screen, that's the SIR, the Science Evaluation Room, where team members are continuing to work through all of the targets that the crew is photographing today, and they've helped identify some of the craters and some of the other items that the crew has seen on the moon's surface. Down on the right is Artemis Mission Control here in Houston. Those two rooms down at the bottom are just down the hall from each other. And we are just a few minutes away from the next cabin and window team swap. That means Victor and Christina, who have been at the windows, will fly to the cabin, the background essentially, and be their support crew for Reed and Jeremy. Reed and Jeremy will move back up to the windows.
Terrible. Donc l'idée, voilà, c'est de rester dans les conditions de vitesse qui amèneront le bouclier à fonctionner correctement sans mettre en danger l'équipage. Et c'est pour ça qu'on va rentrer directement dans l'atmosphère sans faire la même technique que Artemis 1. Normalement, on devrait surpasser, c'est ce que dit la NASA. La NASA, des fois, n'est pas très précise mais, dans leur communication. Mais on devrait surpasser en vitesse de rentrée atmosphérique toutes les missions précédentes des vols habités. Plus de 40 000 km/h. Sauf que la NASA, elle indique dans ses dossiers de presse environ 25 000 miles per hour, donc miles par heure. Donc entre 10,95 et 11,40 km/s. Mais la trajectoire qui a été faite, initialement, on était plutôt sur les 11,06 km/s, tandis qu'Apollo 10 était à 11,094. Donc en fait, ça va se jouer à pas grand-chose, à quelques km/s, enfin même pas à des km/s, à quelques miles par seconde. Et donc, on va voir ce qui va se passer. On va voir ce qui va se passer. Je pense qu'on n'aura pas la réponse à cette question de savoir si Artemis 2 va battre Apollo 10 ou pas, tant qu'en fait tant que Artemis ne sera pas rentré dans l'atmosphère et que la vitesse sera calculée pour qu'on sache si finalement c'est bien Artemis 2 qui a battu le record de rentrée atmosphérique. Mais on n'est vraiment pas très loin de la vitesse d'Apollo 10. Donc ils ont dit que la mission surpasserait en termes de vitesse la rentrée atmosphérique. On verra parce que ça se joue vraiment à pas grand chose.
Another rundown of just how this flyby is choreographed inside the spacecraft today. So these
Julien dit du fois que la force de gravité, il n'y a pas besoin d'une forte correction pour revenir sur Terre. Non, il n'y a besoin de rien du tout, puisqu'on a calculé précisément pour que la Lune nous fasse tourner un petit peu et nous ramène sur Terre. Mais encore une fois, c'est pas la Lune qui nous ramène sur Terre. Si la Lune disparaissait là maintenant, la capsule reviendrait quand même sur Terre. Il y a 8000 personnes qui me demandent comment est-ce que la capsule a passé la ceinture de Van Allen. Je ne sais pas pourquoi les ceintures de Van Allen vous stressent autant, puisque le plus dangereux pour nos astronautes d'un point de vue radiation, c'est les éruptions solaires. Pour les ceintures de Van Allen, c'est des ceintures qui ne sont pas totalement homogènes. Il y a des endroits où on passe qui sont beaucoup moins radiatives, et donc c'est ce qu'on fait pour les missions Apollo. Pour les missions Apollo, on est passé dans ces zones-là. Sachez qu'une mission dans l'espace vous amène moins de radiation que quand vous passez un scanner, pour vous donner une idée sur les missions Apollo. Toutes les missions Apollo ont emporté des mesures qui ont permis de confirmer le nombre de...
And I want to let you know that Jeremy's family have arrived in the viewing gallery. I have no new vehicle updates for you, but I do have a photo location.
Okay, Jenny, we copied most of that. The only thing we're missing is what you meant about the photo location on Victor's PCD.
Ok, donc je n'ai pas de nouvelles à vous donner sur le véhicule. Par contre, j'ai des nouvelles à vous donner, voilà, pour d'un endroit.
I'm glad they made it into the viewing room. And we copy. It's time for crew swap. The A team's coming out of the windows, and the B team's going in.
Okay, copy. All I meant to pass for Victor's PCD is that there are some late load photos that were requested that are now in his favorite photos folder. And you're exactly right. We have Catherine and Devin here. They give you a big wave, and they're super excited and happy to see part of what you're seeing.
Sachant qu'effectivement, les radiations, on reste quand on va sur la Lune sur des missions de courte durée, protégé par un vaisseau. On n'anticipe pas toujours, mais en tout cas, on commence à connaître de mieux en mieux les éruptions solaires, la direction. Donc, on a plein de satellites qui observent ça, qui sont capables de savoir dans quelle direction l'éruption est faite, quand est-ce qu'on va recevoir la dose de radiation, etc. Et donc, c'est plutôt pour Mars qu'on va avoir tous ces problèmes, parce que les missions seront beaucoup plus longues. Et on va vraiment s'éloigner très très fort de la Terre. Donc là, on est déjà sur la Lune, on est déjà plus dans la magnétosphère terrestre, mais pour Mars, ça va être encore pire. Et donc, il y a beaucoup d'expériences, beaucoup de nouveaux matériaux, des essais. D'ailleurs, il y avait un CubeSat dans la fusée SLS qui a envoyé Artemis 2, qui a été largué par le deuxième étage ICPS, qui va tester des matériaux justement contre les radiations avec des pièces de rover à l'intérieur qui vont être donc il y a plusieurs matériaux de protection et on va voir selon tel type de matériaux le radiation qu'on reçoit et donc bien sûr il y a des travaux qui sont en cours pour protéger nos astronautes de nos radiations. Une des hypothèses de travail, c'est qu'on enverrait des astronautes qui ont plus de 50 ans sur Mars parce que comme ça le niveau de radiation qu'ils prendraient n'augmenterait pas suffisamment leur taux potentiel de finalement de déclencher des cancers ou des problèmes, puisque ça va être triste à dire, mais les astronautes seraient décédés avant de déclencher un problème, puisqu'ils auraient plus de 50 ans. C'est une des pistes, il y en a plein, comme je vous le dis, des pistes techniques, notamment sur le fait de protéger les astronautes correctement par divers matériaux. Certains veulent mettre de l'eau, d'autres sont en train de fabriquer des matériaux destinés à ça. Et donc, et ben voilà, on est parti pour tenter de ça. Mais je sais pas pourquoi les complotistes font une obsession sur les ceintures de Van Allen, c'est assez marrant. Comme si d'ailleurs ils avaient une foutre idée de ce qu'étaient les ceintures de Van Allen. Ou une fichue idée. Une fichue idée.
With that call to make the swap, Reed and Jeremy will be back at the windows, making observations for what they see at the moon and taking photos.
Et d'ailleurs, j'aurais peut-être pas dû dire que les scanners, il y avait plus de radiation, parce que peut-être qu'après, certains complotistes ne vont plus aller se faire soigner. Allez vous faire soigner, les amis, pour passer des scanners. Voilà. Si le médecin vous le préconise. Et si on vous le préconise pas, faites pas de scanner. Hein. Parce qu'après ça va être cut et déformer mes propos. Est-ce qu'on peut voir la capsule au télescope une fois que la Lune sera sortie? Alors je sais qu'il y a des télescopes qui arrivent à suivre très très bien la capsule. Je connais vraiment pas suffisamment l'astrophotographie. Mais si c'est possible, je pense qu'il y a des gens extrêmement doués qui vont nous faire des photos de folie.
Houston, a little preview of what's to come, but something that's really awesome up here is we now have the moon and the Earth in window 3 simultaneously, and the moon is a gibbous, and the Earth is a crescent. And I'm guessing in about 45
Alors, on
minutes,
s'interroge sur Glover qui dit qu'il y a la Terre qui les éclaire. On va reprendre cette petite simulation. Donc voilà, on nous précise que la Lune est un croissant. Et donc voilà, il nous dit que maintenant, d'où ils sont, ils voient la Terre est un croissant et que du coup, la Terre et la Lune ont inversé leur position. Parce qu'effectivement, pour eux, je pense que ça ressemble plus ici à une planète éclairée et la Terre ressemble plus à une Lune avec ce croissant de Terre qu'ils doivent être en train de voir. J'espère qu'ils vont pouvoir nous faire une photo. Mais du coup, effectivement, ils ont un petit croissant de Terre actuellement. Ils doivent voir quelque chose comme ça.
Now, obviously, our view is from a camera on the solar array wing pointed at the moon. We hope to see that view of both the Earth and the moon soon.
Donc, ils espèrent avoir une vidéo de la Lune et la Terre bientôt. C'est ce qu'ils viennent de dire. On est en dessous des 10 000 km, on peut les applaudir, on s'approche de la Lune. On est à 9 914 km de la Lune.
Shortly after, just a few minutes later, we will lose signal with the Orion spacecraft. This is tracked as it is going behind the moon and out of reach of the Deep Space Network. At 6 o'clock p.m., the spacecraft will make its closest approach to the moon at a distance of about 4,066 miles. At 6:02 Central, the spacecraft will reach its farthest distance from Earth at about 252,755 miles. Of course, these are approximate, and we will make sure to provide you with the final distances once those are confirmed. At 6:21 p.m., we will have Earthrise from the Orion spacecraft, but we will not have communications with the spacecraft until 6:25 p.m. Central, when we expect to acquire signal with them after they've emerged from behind the moon.
Donc, ils sont actuellement à une vitesse assez faible de 0,42 km/s, parce qu'on pose la question dans le chat. Sacha Touy dit, pour les radiations vers Mars, on pourrait peut-être fabriquer des sortes de sacs de couchage anti-radiation sur lesquels dormiraient les astronautes. Je suppose qu'on y a déjà pensé. Bah, tu penses pas mal, puisque dans la mission Artemis 2, dans les caissons dont je vous parlais tout à l'heure, hein, où ils doivent aller en cas d'éruption solaire, et bien effectivement il y a des sacs de protection. Donc c'est pas du tout voilà, une mauvaise question, une mauvaise idée, puisque c'est déjà en place. Donc effectivement, dans la capsule actuellement, il y a des sacs de protection pour ça.
We've heard great calls from the crew so far describing what they're seeing, all well trained by the science team here on the ground. Another major milestone for the crew today will be to experience a solar eclipse from their capsule. No one on Earth will experience this solar eclipse.
Effectivement, je peux vous remontrer parce que je suis de mauvais côté.
Whereas if you're standing on Earth and looking at a solar eclipse, the moon and the sun appear to be about the same size in the sky.
Voilà un petit peu ici la télémétrie. Ça se voit que c'est une télémétrie calculée ici, puisque la NASA a eu la bonne idée de ne pas mettre de télémétrie. Donc on est à 9758 km de la Lune et à 405 147 km de la Terre. Donc là, on nous parle que tout à l'heure, ils vont avoir le droit à une éclipse solaire, hein, le soleil qui va passer derrière la Lune, du point de vue de l'équipage, et donc ils vont pouvoir prendre en photo la couronne lunaire.
Saturn, Mars, and Mercury will be near the sun, so they may be able to identify what part of the sky they're looking at. This can help train future Artemis astronauts on what part of the sky they're seeing, which is useful knowledge in challenging situations when they may need to rely on that information instead of instruments for navigation and orientation. That eclipse window will last about an hour, and it'll happen near the end of the day today, closer to 7:35 p.m. Central, 8:35 Eastern.
Bon, je vois que vous êtes beaucoup à vous plaindre de la qualité de la diffusion de la NASA. On ne pourra rien y faire. Et oui, vous avez raison, la NASA aurait dû mieux se préparer. Mickey Beatty, le site, il est sur Artemis 2 Tracker sur GitHub, si ceux que vous voulez aller le voir. J'ai pas le lien, peut-être un modérateur peut mettre le lien s'il le trouve. Guépi Marius qui demande, mais à 6000 km de la Lune, ils auront toute la couronne solaire? Non, oui, t'as bien fait de poser la question, mais en fait, le point le plus proche sera atteint à 1h02 du matin, donc UTC plus 2 heures de Paris. Et par contre, l'éclipse solaire commencera à 2h35. En fait, ils seront déjà sortis, ils auront déjà le lever de Terre. Donc on aura déjà récupéré la connexion avec eux depuis 1 heure. Et après, il y aura l'éclipse solaire. Donc c'est pas des événements qui sont concomitants.
As you can see in this live view from Orion, the Earth is, the spacecraft is maneuvering around the moon, and the views of the moon have changed since we started our broadcast.
Crevette a posé le lien dans le chat YouTube et Renix sur le chat Twitch si jamais. Sur GitHub si vous voulez aller voir vous-même le site que j'ai montré tout à l'heure.
Tele Quisqueya, la marche à suivre. Et t'es branché, et t'es connecté.
And this is a crater that was previously never seen before by human eyes until this mission.
Le petit Nicolas, en quoi le programme lunaire chinois diffère-t-il de celui-ci? Il va pas vraiment différer de celui-ci, puisque le programme chinois ressemble beaucoup au programme Apollo, avec un alunisseur et une capsule pour les amener, un petit peu comme il va y avoir ici. Je pense que la principale différence entre le programme chinois et le programme américain, ce sera le Starship de SpaceX, puisque si le Starship fonctionne, on aura de gros tonnages à amener sur la Lune. Donc, on aura du gros tonnage à amener sur la Lune. Donc, la capacité des Américains à construire une base lunaire sera largement supérieure aux Chinois. Voilà. Donc, je pense que c'est vraiment le... Pourquoi je dis si? Parce que si jamais c'est Blue Moon de Blue Origin qui gagne, on sera quasiment sur les mêmes technos, entre guillemets. Blue Origin sera quand même un petit peu plus peut-être moderne, si tant est qu'on peut considérer qu'Apollo n'est pas moderne. Et du coup, le programme chinois, voilà. Donc on va faire un peu la même chose, mais effectivement, si le Starship fonctionne, gros avantage au programme américain.
Having a crew means we have to have an environmental control and life support system. There's a lot of data around, a lot of data to bring down for the crew members.
Quand le prochain lancement de Starship, demande Reynald, pas avant 3-4 semaines, elle a dit Elon Musk, mais Elon Musk il dit 3-4 semaines, toutes les 3-4 semaines. On a appris par contre qu'ils ont modifié le plan de vol possible pas du prochain vol, mais de l'après-prochain vol. Je sais pas si ça se dit en français, ça, l'après-prochain vol, vous avez compris. On pourrait avoir un vol orbital dès le vol, pas le prochain, mais l'après-prochain. Donc ça serait très cool. Et ils ont même demandé, voilà, donc on aurait un deuxième étage orbital, et ça accélérerait largement le programme. Mon compte, bonjour UFO, pourquoi ne pas utiliser le même bouclier thermique que celui d'Apollo? Il a fait ses preuves, non. On utilise quelque chose d'assez similaire, hein. Même si c'est pas le même bouclier tout à fait. On utilise une technique de bouclier ablatif assez similaire.
Houston Integrity for SITREP. First of all, I'll just talk about the experience that I had.
Nicolas dit lors de l'éclipse, quelle taille fera la Terre par rapport au diamètre apparent du Soleil et de leur position?
We definitely
Aucune
noted
idée.
how much more you can see with the zoom lens. Even though we have a great visible eye image, there's just a lot of texture that just pops right out at you when you can zoom in. So almost just using it like a telescope, the camera lens. We really enjoyed our discussion time. That was a great innovation on the lunar targeting plan. We were both able to describe a lot more kind of with flow, I would say, when we were talking to each other. And it was also, we sort of were able to bounce ideas off of each other and come to new conclusions. We had, I think, a very successful talking through of some contacts between different color areas, both in the Mare and in the Highlands, and we identified some really unique texture areas as well. At one point, towards the end of the images of my time in window 3, I just had an overwhelming sense of being moved by looking at the moon. It lasted just a second or two, and I actually couldn't even make it happen again. But something just drew me in suddenly to the lunar landscape, and it became real. And the truth is, the moon really is its own body in the universe. It's not just a poster in the sky that goes by. It is a real place. And when we have that perspective and we compare it to our home of the Earth, it just reminds us how much we have in common. Everything we need, the Earth provides, and that in and of itself is somewhat of a miracle, and one that you can't truly know until you've had the perspective of the other. I'll switch into some logistics stuff. The Peltors, both their batteries stopped providing the active listening, but we have verified they are still recording, and so we are able to have discussion time and hear outside our recordings by just moving the ear cup off of the ear. Other than that, everything's working well technically, and we've been able to find all our targets, and we're having a really great time.
Thanks, Christina. We copy those logistics for the Peltors, and also thanks for bringing us into the cabin with you with that description.
We're having a really great time.
Petit point d'étape de Christina à la NASA. Pour dire que voilà, elle a parlé un petit peu d'endroits qu'ils ont vus sur la Lune et que pour l'instant bah, tout allait bien.
Right on time. NASA astronaut Christina Cook, a mission specialist for Artemis 2, calling down a science SITREP, a situation report. Good news, reporting that she and her teammates have been able to capture all targets that were listed.
Elle a confirmé qu'ils ont capturé toutes les cibles qui ont été listées en photo.
Integrity cabin team for window shroud.
Just how it feels to be there and to see the moon up close and not just something passing in our night sky.
Et là actuellement sur l'image on a à peu près, je dirais la moitié de la partie éclairée qui est la face cachée de la Lune qu'on voit pas depuis la Terre. Je dirais que ça s'arrête à peu près là. La face visible et la face cachée qui est ici. Et bien sûr, on a une partie de la face cachée qui est dans l'ombre actuellement.
And the shroud might be getting us close, so we just want to check on the state of window 4's shroud.
Et dans un peu moins d'une heure, d'ici une cinquantaine de minutes, on sera au point le plus proche de la Lune. Enfin, pardon, je me suis trompé. Ça sera à 1h02, pardon, le point le plus proche de la Lune. Donc on a encore un peu de voyage.
Unfortunately, since it's been on for a while, we are going to have to request that the shroud is removed, and we can recommend something that could block the light but just create a bit of
Donc il
distance
dit, j'ai l'impression qu'il, je sais pas ce qui va les gêner, mais ils ont dit oui, si on fait ça, ça va nous gêner probablement pour la vision et pour le confort.
Unfortunately, since it's been on for a while,
Okay, we're removing the shroud and we'll make it work. Thanks.
And we can recommend something that could block the light but just create a bit of distance between the window and whatever is covering it. Something like a t-shirt would do the trick and help.
Donc ils ont dit malheureusement ça fait trop longtemps que vous avez masqué le hublot, il va falloir le démasquer et si ça vous gêne, il faudrait utiliser quelque chose qui est plus loin du hublot, peut-être un t-shirt pour essayer de masquer la lumière qui vous gêne.
Thank you, Victor. We know it's pretty bright in there now with that window uncovered.
You can easily point a diffuser at the window, so we're going to start with that, and it's pointing at the window now.
Also retrieve the condensation hose, which should be friction fit onto one of the diffusers, and that on the window would also help. We'll take that, Victor. Thank you. Please keep us updated.
Et donc il leur dit qu'on va peut-être vous mettre
Tele Quisqueya.
Okay, we'll take that, Victor.
Tele Quisqueya. La marche à suivre. Et t'es branché. Et t'es connecté.
Alors, c'est marrant quand même de voir ces petits détails là, d'entendre ces petites conversations parce que on se dit que la luminosité, ou en tout cas ce qui pourrait gêner les astronautes à l'intérieur de la capsule aurait été calculé, prévu à l'avance. Mais on se rend compte que non. On se rend compte qu'il y a un petit débat entre Houston et les astronautes. Enfin, pas débat, mais voilà, je trouve ça marrant de voir cet instant de vie parce que ça veut dire qu'on n'a pas mesuré l'incidence de l'éclairage de la Terre, de la Lune ou du Soleil à l'intérieur de la capsule pour que les astronautes puissent faire ce travail d'observation de la Lune à ce moment-là. C'est un petit peu étonnant quand même. Donc ce qu'ils nous ont dit au départ, c'est que c'était la luminosité de la Terre qui les gênait. Sur l'hublot numéro 4, c'est pour ça qu'ils l'ont masqué. Et a priori, ça pose problème de le laisser masquer. Est-ce que ça pose problème d'un point de vue thermique, de condensation peut-être? Je pense que quelqu'un posera la question dans la conférence que la NASA fera après le survol. Il y a le TV qui nous dit comme quoi il y a toujours une part d'imprévu, effectivement. Nancy qui dit merci, j'ai appris qu'on voyait qu'une seule face de la Lune, je vais mourir moins bête. Pas de problème. Alors après c'est vrai que c'est un peu c'est un petit peu contre-intuitif, puisque la Lune tourne sur elle-même. On a l'habitude qu'on nous présente les planètes, les satellites qui tournent sur eux-mêmes. Mais c'est vrai que la Lune, c'est quand même très particulier pour la planète Terre, puisqu'en fait, eh bien, elle sait sa manière de tourner autour d'elle.
Walking around down there on the surface, climbing and off-roading on that amazing terrain. I also want to underscore something that she said. As we continue to explore, when we actually do go down there to the surface, I know for safety reasons that we would never send someone alone, but I just want to really emphasize how important the discussion time was. When we started to talk, we not only got better science discussion, we got better human connection, and so doing this as a pair, we just learn and grow together, and that's just super important. So thank you for adding that to this plan. Reed just passed me a note that the Oriental Basin annular ring has a similar albedo to the center, but a different color. It has more brownish tones in it, and he said it's very distinct now that he's been staring at it. They grow together, and that's just super important.
Victor, thank you. You got a cheer from science there, and we all just went on that moonwalk with you, so highlighting how important it is to talk about these things. I also want to let you know that we have...
Donc elle dit merci de faire, si j'ai bien compris, de faire ces expériences à deux, même si on ne verra jamais personne tout seul. Et que le fait de discuter ensemble, eh bien, ça permettait d'avoir le meilleur retour et une meilleure connexion humaine. Et après, il a dit que il lui a passé une note pour dire que voilà, il redécrit les histoires d'albédo sur la planète, sur la Lune, de ce qui a été observé. Donc ça rigole. Donc voilà, ils ont leur fille avec eux. En fait, c'est marrant parce qu'ils mélangent des ils mélangent des messages perso avec des messages plus techniques où ils expliquent leurs observations. Donc ça saute du coq à l'âne dans les communications.
We've had some really sweet words from the crew members aboard Orion today as their families have been able to filter in and out of the viewing room here at Artemis Mission Control.
Donc voilà, la famille qui a pu venir dans le centre de contrôle de mission. Donc c'est pour ça qu'ils se sont permis des petits messages personnels.
He also expressed how important it was to be able to talk through that real time with Christina Cook and stress the importance of that on future missions, that it not only made their discussions better but also more human.
Donc il a rappelé la nécessité, l'importance de discuter avec Christina pendant les observations et c'est vrai que je l'ai pas dit, mais il a remercié la NASA finalement d'avoir mis ses capacités au plan, je pense, de travailler finalement en équipe sur ces observations et pas tout seul. Merci Oli Gavik pour ton don de qualité, merci à toi.
Once Glover and Cook return to the window portion of their flyby today, Reed Wiseman and Jeremy Hansen will get into their midday meal.
Salut Kanawab. Bienvenue les amis sur Twitch. On est déjà 3137. Merci aussi sur YouTube, on est 102 450. Merci à vous. N'hésitez pas à vous abonner, je pense que vous êtes déjà tous abonnés. Et à cliquer sur la clochette de notification. Si vous aimez les événements spatiaux, commentez en direct en français. Il va être long ce live, vous inquiétez pas, on va rester là jusqu'à tard.
Tele, Quisqueya.
23h26, eh bien, écoutez, il nous reste à peu près 1h10 avant de perdre le contact avec l'équipage qui va passer derrière la Lune. J'ai hâte, j'espère qu'on aura les images du coucher de Terre, puis du lever de Terre, depuis la capsule. Alors, malheureusement, on n'aura pas meilleure qualité, mais on voit que... J'aime pas du tout cette caméra, je préfère l'autre. Remettez-nous l'autre, s'il vous plaît. On voit quand même que la Lune se rapproche. Petit point d'étape de nos amis avec le petit simulateur. 8190 km de la Lune. On se rapproche. Je rappelle qu'au plus près, on sera à 6550 km. Donc on va encore gagner 2000 km. Et la Lune est en train de passer. Donc vous voyez que la face visible de la Lune, elle est plutôt comme ça. Et que là, on a quand même une bonne portion de la face cachée de la Lune qui est actuellement observée depuis cette vue-là.
A couple of the other features in view right now are Hertzsprung Basin and Vavilov Crater. Hertzsprung Basin is nearer to the center of the moon, closer to that terminator line right now.
Ah, cette caméra est mieux. C'est vrai qu'on aurait aimé une meilleure qualité pour voir un peu les détails de la Lune, parce que là on voit le nombre de cratères qui commence à augmenter. Les deux faces sont assez différentes, hein, puisqu'il y en a une qui a pris un max de frappe, hein, d'astéroïdes, de météorites. Et donc, je pense qu'on va avoir des sacrées photos, hein, des cratères, hein, qui marquent la surface. Donc les autres vues sont à peu près d'un tiers de la Lune. I can only see about half of it. I'm looking through the docking hatch window right now because we have the Z9 in window 1. But that Terminator has moved. I guess I've been using Vavilov the whole time, so it's gone with two more Vavilov craters. Donc, ils sont en train d'observer un cratère avec plein de cratères autour de lui, un peu au niveau du Terminator partie sud. Low sun angle, and so you still have ridges and moved and valleys showing up very clearly. A very jagged Terminator and a few islands of light as well there with some high elevation shining in the sunlight in that darkness. Donc effectivement tous les cratères qu'on voit, on les voit bien quand même au niveau du Terminator, là même sur la droite. Hein. Tous ces cratères, hein, qui ont été formés par des impacts qui sont survenus tout au cours de l'histoire de notre système solaire. Et c'est un peu une sorte de registre des conditions autour de la Terre et de la Lune. Parce que la Terre aussi a subi quand même pas mal d'impacts au cours de son histoire, mais dont un qui a priori a eu une grosse conséquence sur les dinosaures. Mais en fait, nous, sur Terre, entre la tectonique des plaques, l'érosion, le volcanisme, en fait, les cratères, si on regarde bien, nous, on n'a pas l'habitude de les voir sur notre planète Terre. C'est pas quelque chose qu'on fréquente souvent. Alors que la Lune, on peut constater qu'elle a pris cher et qu'elle est restée comme ça. Pas d'atmosphère, donc elle a gardé cette histoire. Et donc, nous, on l'a pas sur Terre. Même si on a des cratères, hein, qu'on peut visiter, mais vous voyez, pas autant que la Lune. Et du coup, la Lune, ça permet aux scientifiques d'étudier tout ça, puis de compléter un petit peu le tableau de l'histoire de notre planète, hein, de la planète Terre, grâce à ces cratères qu'on a sur la Lune. Et donc, ça va être super intéressant quand on aura des êtres humains là-bas. Donc, première chose qu'ils vont faire, c'est chercher de l'eau. Ça, on comprend que c'est l'obsession de l'être humain. Mais il va y avoir quand même des géologues qui vont aller là-bas pour analyser tout ça. Et ça va nous en apprendre plus sur le passé de notre planète, pas forcément que sur la Lune. Et ça, c'est plutôt cool. Pour en revenir sur la Lune, tout à l'heure, je sais plus qui posait la question. Je pense que j'aurais plus le chat. Je suis désolé. Mais effectivement, voilà, certaines personnes ne le savent pas, mais effectivement, la Lune nous montre toujours la même face, tout simplement parce que sa période de rotation, donc sa période sur laquelle elle tourne sur elle-même, est égale à sa période de révolution. Et donc, en plus, elle est synchrone avec... du coup, ça la rend synchrone avec la Terre. Et ça, alors il y a plein de théories, hein, alors, je sais même pas si on dit des théories ou si c'est vraiment avéré à 100%, mais c'est la force des marées entre la Terre et la Lune qui ont ralenti la rotation lunaire à tel point qu'aujourd'hui, ben, c'est la même face qui est présentée à la Terre. Et en plus de ça, la Lune, ce qui est un peu particulier, c'est que si on regarde la partie droite, mais qu'on a passé, donc pour ceux qui étaient au début du live, vous l'avez bien vu, et ceux qui sont arrivés plus tard, tant pis. Bon, on a vu quand même qu'entre la face cachée et la face, alors on voit un petit peu encore ici la face pas cachée, et en fait on a tout ce qu'on appelle les mers, là, vous voyez ces taches un peu foncées, on en voit quand même une grande ici. Et on voit qu'on n'est pas sur la face cachée, on est totalement dans un univers différent presque. On a vraiment une différence assez distincte dans l'apparence entre la face visible et la face cachée. Alors attention, on dit des mers, hein, mais c'est pas des vraies mers, hein. C'est historique, hein, au XVIe siècle, hein, les astronomes qui pensaient que c'était des mers. C'est pour ça qu'on a gardé ce nom-là en latin. Et voilà. Donc en fait, c'est vrai que la Lune, c'est quand même assez particulier d'avoir cette synchronisation, d'avoir une synchronisation, de voir toujours la même face. C'est vraiment assez particulier, je trouve. Et en plus de ça, les deux faces sont vraiment différentes. Probablement parce que il y a une des faces qui est beaucoup plus exposée, elle n'a pas la planète Terre devant elle, donc elle va se prendre de toutes les météorites, et je pense que la Lune nous a permis d'éviter aussi quelques impacts. Ça nous fait un petit bouclier de protection.
That is great feedback operationally. Thanks, Victor. I'll leave you to it.
French qui nous dit la tache noire, c'est marée orientale, environ 300 km de diamètre. Donc j'imagine que tu parles de celle-là, ici en bas à gauche.
Science integrity with a question from the window team.
Integrity, this is Science here with you.
Yes, they have a question to help inform a theory that they're sort of tossing it back and forth. What is older, the Mare seas of the near side or Oriental?
Integrity, this is Science here with you. Stand by, Integrity. We're going to get you a little geologic history here.
They're sort of tossing it back and forth. What is older, the Mare seas of the near side or Oriental?
En fait, ils sont en train de demander à Houston qu'est-ce qui est le plus vieux entre la mare orientale et l'autre, j'ai pas entendu. Ils sont curieux de savoir géologiquement laquelle est la plus ancienne. Il faut savoir en plus qu'entre les deux faces cachées, les amis, ça c'est un truc de ouf sur la Lune, c'est que, et je crois qu'on a appris ça grâce à une mission japonaise, en fait la croûte de la face cachée, c'est pas la même que la croûte de la face visible. Ça c'est quand même un truc de ouf aussi. La Lune, on dirait vraiment qu'elle a été coupée en deux, quoi. La croûte de la face cachée, faut pas se tromper, elle est plus rigide, plus froide et elle est plus résistante que la face visible. Alors aujourd'hui, on n'a pas de certitude à 100% du pourquoi, du comment, mais en fait, ça affecte même le champ de gravité. Le champ de gravité, il est différent entre les deux faces lunaires. C'est quand même fou, non? Et donc, il y a plein de recherches autour de ça. Donc, j'ai hâte justement que des humains aillent là-bas pour essayer de résoudre un petit peu ces énigmes autour de la Lune. Mais il y a plein d'énigmes comme ça quand on essaye de de se plonger dans un astre, on se rend compte qu'en fait, il y a plein de questions. On connaît beaucoup de choses, on est capable d'envoyer des êtres humains autour de la Lune, mais il y a des énigmes comme ça, assez folles, de cette différence entre les deux faces de la Lune, qui sont... Alors, c'est une histoire de densité, hein, l'histoire de gravité différente et tout. C'est repéré par nos sondes, justement. Et il va falloir après trouver, il y a des hypothèses qui sont amenées, et il va falloir aller chercher géologiquement pour essayer de comprendre ce qui s'est passé. Il y a plein d'hypothèses. Aujourd'hui, on n'a pas de certitude du pourquoi il y a cette différenciation entre les deux faces de la Lune.
And Kelsey, thanks for that. We love lunar volcanism too. How about when the actual crater was formed?
Et la Lune, en l'occurrence, on a de la chance, c'est plein de mystères. Donc les astronautes qui vont aller là-bas et je pense que les géologues et les scientifiques vont se régaler sur la Lune pour essayer de comprendre tout ça. Et déjà, ceux qui vont réussir à aller sur les pôles sud, se poser, commencer à chercher de l'eau, essayer d'exploiter l'eau pour la consommation, pour la fabrication d'oxygène, pour la fabrication de carburant potentiellement, ça va être quand même une sacrée aventure qui nous attend dans les années qui arrivent. Je ne sais pas ce que vous en pensez, mais on va vivre des beaux moments. Kanawab qui dit, j'ai une chose que je n'ai pas compris sur le short de TF1 qui disent que c'est la première fois que l'homme voit la face cachée de la Lune. Ils ont tort, non. Alors on peut pas en vouloir à TF1, Kanawab, parce que c'est la NASA qui a fait un tweet en disant ça. Et effectivement, c'est faux. Il y a déjà eu des observations de la face cachée de la Lune. Pas entièrement, mais finalement comme eux là. Et donc, je sais pas pourquoi la NASA a dit ça. En fait, la NASA a dit ça, mais NASA Johnson sur X a fait à peu près le même tweet en précisant que c'est la première fois que certaines parties de la face cachée de la Lune seraient vues par des yeux humains, et ça c'est vrai. Donc voilà, c'est un peu compliqué. La NASA qui diffuse ça, c'est vraiment la porte ouverte à toutes les fenêtres, en l'occurrence, à toutes les problématiques de complotisme, qui se sont bien sûr empêchés qui se sont dépêchés de retweeter la NASA et de dire qu'en fait, la NASA avoue qu'ils n'ont jamais été autour de la Lune avec Apollo à cause de cette phrase malheureuse, qui n'a toujours pas été corrigée d'ailleurs par la NASA, je crois, à cette heure-ci.
Perfect. Tracking. Thank you.
Étape sur la trajectoire, on est actuellement à 8243 km de la Lune et on attend tranquillement, on voit que la gravité lunaire est en train de nous attirer et la Lune va passer dessous. C'est la Lune qui va le plus vite actuellement et qui va nous passer dessous sur cette trajectoire, et ça va nous permettre de ne pas tomber sur la Lune puisqu'elle va se décaler et nous on aura suffisamment de vitesse relative pour aller repartir directement vers la planète Terre. Encore quelques temps, hop là, tac, 3h du mat, on va essayer ici, j'aurais bien aimé de me mettre à minuit 44, ok, ouais, alors là, hop, en fait à minuit 44, on devrait perdre le contact avec l'équipage, mais je pense pas qu'on puisse précisément changer la date. Hop, on peut pas, on est obligé de sauter 1h03, voilà, minuit 44, on devrait perdre la communication avec l'équipage simplement parce qu'ils vont passer derrière la Lune, ou la Lune va passer devant nous, c'est comme vous voulez. Gaël qui nous dit la différence de densité est expliquée dans le film Iron Sky. Je pense pas l'avoir vu. Et quelle est la théorie dans le film Iron Sky?
Integrity, it's about time for a position swap at the window. So we will ask.
Ok, Integrity, il est temps pour faire un switch, un changement d'équipe sur les fenêtres. Et donc, ils vont alterner leur place.
We will ask that you retrieve the condensation hose and you install it on a friction fit on the cabin air outlet port. That's right by one of your diffusers. You're going to point that little condensation hose such that the air is flowing over the window pane. Let me know when you're ready for the stowage location.
Donc quelqu'un me dit que la théorie c'est que à cause des météorites on aurait apporté sur la face cachée du matériel quoi sur la Lune, ce qui justifierait. Alors du coup la mission Selene, si je dis pas de bêtises, la mission japonaise, elle a produit des cartes qui tendent à montrer que justement c'est pas cette hypothèse là qui serait la plus probable. Ça serait plutôt dû à des remontées plus anciennes de matériaux denses qui sont remontés à la surface plutôt que par des apports extérieurs. En tout cas, voilà, c'est ce qu'a montré Selene, tout simplement parce que les pics du champ de gravité dont on parlait tout à l'heure, eh bien, ne coïncident pas avec la présence des impacts. Donc en fait, il y a des bassins où il y a plus d'impact, donc c'est là où on s'attendrait à avoir un champ de gravité plus fort si c'était dû au remplissage des bassins par des grosses météorites. Et en fait, on se rend compte que ça correspond pas. Donc c'est probablement autre chose. Et une des hypothèses, c'est la remontée de matériaux denses. Après, la raison du matériel de la remontée de matériaux denses, aucune idée. Ça, je vous dis, je suis pas un spécialiste cosmologique sur le sujet. Mais si quelqu'un a des infos, n'hésitez pas à balancer dans le chat. Lionel nous dit ce sont les remontées de magma chargées de fer et de nickel. Voilà, vous avez toujours des spécialistes dans le chat. Draxis, vous pensez qu'ils vont pouvoir photographier le drapeau posé par Apollo 11? Non. Déjà pour une raison simple. Allez, petite anecdote drapeau sur la Lune. Ok. Il y a 6 drapeaux qui ont été plantés sur la Lune. Il y en a un, on sait qu'il est plus planté, c'est le drapeau d'Apollo 11, parce qu'il a été planté trop près de l'alunisseur qui a redécollé, et donc il a été soufflé au moment du décollage. Donc celui-là, on sait qu'il est plus planté. On est sûr qu'il y en a 4 qui sont plantés parce que les orbiteurs les ont pris en photo, donc vous pouvez aller les trouver sur internet, et on est sûr qu'ils sont plantés. Il y en a un, on n'est pas sûr, parce que il y a doute sur les images. Est-ce qu'il est planté, est-ce qu'il n'est pas planté? Il y a doute, voilà. Donc actuellement, officiellement, il y a 4 drapeaux plantés. Un drapeau potentiellement planté, on pense qu'il est là, mais c'est pas tout à fait confirmé. Et un, on est sûr qu'il a été soufflé. Et en plus, comme je l'ai dit au lancement, j'avais déjà dit cette anecdote-là, mais les drapeaux ne sont plus des drapeaux américains, ce sont des drapeaux blancs, parce qu'avec les radiations, ils ont perdu leur couleur. Et donc aujourd'hui, on a 4 ou 5 drapeaux blancs à la surface de la Lune.
That loss of signal will last about 40 minutes, and we expect to regain communications with them once they fly behind the other side.
Est-ce qu'on a des images du crew? Oui, on en a, mais pas pour l'instant. La NASA les diffuse pas encore pour l'instant. Donc pour l'instant, ils filment. Je reste sur cette vue parce que c'est celle qu'on a vu en plus grand. Parce que sur l'autre live de la NASA, on voit la salle de contrôle, mais quand ils passeront sur les vues de l'équipage, on changera.
From a camera on Orion's solar arrays. You are looking at a live view of the moon, and 4 people are inside that spacecraft taking pictures of it, telling us everything that they are seeing. The first humans to do so in over 50 years. They'll be sending those pictures down for all of us to enjoy, and of course, especially the science team, who are very excited for what they are learning today. It appears the Artemis 2 spacecraft Orion is now under 5,000 miles away from the moon. Again, we expect their closest distance to the moon be about 4,066 miles.
Houston integrity question, did you just want us to cool the window with the condensation hose, or did you want us to put the shroud back on and cool the window at the same time?
Once we receive it.
Victor, we definitely want you to cool down the window with the condensation hose. It's crew preference whether you put the shroud back on. The hose will allow you to do that if it helps with your lunar flyby.
Donc pour ceux qui aiment bien les énigmes lunaires, hein, les amis, je vois que ça discute là dans le chat de plein d'énigmes lunaires. On en avait parlé lors d'un lancement, les tourbillons lunaires, des formations un petit peu énigmatiques hein, qu'on observe à la surface de la Lune, qui ont un albédo assez élevé. Donc ça on en avait parlé, on ne sait pas trop comment ils se forment. On dit souvent que l'atmosphère, par facilité, que la Lune n'a pas d'atmosphère, mais elle a une atmosphère, la Lune, qui est très ténue, mais elle a une atmosphère, pour info. Je ne sais pas si vous le saviez. C'est vrai qu'on a l'habitude, par facilité, de dire qu'il n'y a aucune atmosphère, mais c'est pas tout à fait vrai. C'est comme quand on dit que la Terre, la différence entre l'espace et la Terre, c'est 100 km, la ligne de Kármán, et qu'après, du coup, il n'y a plus d'atmosphère. Il reste des particules bien au-delà de ces altitudes-là. En fait, dès qu'on rentre un peu dans les détails, on se rend compte que tout n'est pas aussi simple qu'on nous le présente. Et sachez qu'on a même détecté de la vapeur d'eau hein, à différentes altitudes de la Lune. Encore une fois, des hypothèses, hein, la sublimation de la glace d'eau qui est actuellement à l'intérieur du régolithe, hein, donc régolithe, on va dire la poussière lunaire ou les roches lunaires. Et donc il y a plein de choses, assez marrantes sur la Lune à étudier. C'est vraiment pas un astre. On a l'impression que c'est un astre mort. Hein, on nous le présente souvent comme un astre mort et finalement une étape avant Mars, parce que Mars c'est quelque chose qui intuitivement, pour quelqu'un qui connaît pas trop l'espace, ressemble plus à la planète Terre. C'est quelque chose qu'on a plus de facilité à appréhender d'un point de vue de l'imagination, parce que c'est une planète, ça a une atmosphère, donc ça ressemble plus à ce qu'on a. Donc on présente souvent la Lune comme une sorte d'astre mort qui tourne autour de notre planète, mais en fait il y a plein de mystères et plein de choses, voilà, quand on pousse un petit peu, qui sont hyper intéressantes sur la Lune. Donc ça sera pas du temps perdu d'aller là-bas. Déjà le principe du programme Artemis, c'est que tout ce qu'on doit faire sur Mars, on doit d'abord être capable de le faire sur la Lune. Et voilà. Donc la Lune, c'est pas un astre mort qui n'a pas d'intérêt.
Causes the craters that are inside of the larger crater, the smaller craters, to have really sharp edges, And just a general comment on that area, from the whole area, the average albedo there is darker. That is, I would say, 3. And the average albedo around Oriental and between Oriental and Home, excluding the wedge, the darker wedge, is more on the 6-7. And that they also seem to be different texturally. Christina described it earlier around Hertzsprung, and then from Hertzsprung toward Oriental, there appears to be a frozen, a rippling pond that's frozen.
Donc ils sont en train de décrire un des cratères hein, qu'ils observent avec une partie très très sombre, des arêtes très nettes. Donc c'est vrai que c'est difficile, vu qu'on n'a pas les images de ce qu'ils sont en train d'observer, de se faire une idée.
Victor, that's a wonderful description. Going from a paved road to lava reminds us of the Icelandic Highlands. Thanks for that.
Et en parlant d'atmosphère, parce que je vois que dans le chat vous avez un grand débat, pour relancer encore le débat sur l'atmosphère, les amis, sachez que quand on a ramené les échantillons d'Apollo, les échantillons qu'on a récupérés, notamment de magma de la Lune, en fait, ça a tant à prouver que la Lune avait une atmosphère qui était assez épaisse pendant une période de 70 millions d'années, il y a 3 ou 4 milliards d'années, donc ok, ça date un petit peu, mais c'est une atmosphère qui était plus épaisse que celle qu'on voit actuellement sur Mars. Donc vous voyez que la Lune a quand même eu une vie un peu particulière. Pareil, je vois que vous discutez des mécanismes de formation de la Lune. Je suis pas sûr qu'il y ait qu'il y ait encore un... On a acté complètement la théorie sur le sujet. Mais effectivement, là je vois que vous en parlez, l'hypothèse dominante aujourd'hui sur ce système un peu Terre-Lune, c'est que la Lune se serait formée après un impact d'une protoplanète qui avait une taille similaire à Mars quand même. Entre cette protoplanète qui a été nommée, je crois, Theia, et qu'elle est rentrée avec la proto-Terre en fait en impact, ce qui a créé la Lune, tout simplement. Donc ça, c'est l'hypothèse dominante aujourd'hui. Donc la Lune qui ne s'est pas créée parce qu'il y a un bout de l'autre planète qui est resté. Ça, en fait, les deux se sont percutés. Ça a fait un disque de débris. Ce disque de débris, il s'est agglutiné. C'est l'accrétion, on appelle ça. Et dans ce nuage de débris, du coup, ça a formé la Lune. Mais sachez que même cette hypothèse dominante n'amène pas aujourd'hui de... Il y a plein de choses que cette hypothèse n'explique pas. Donc encore une fois, c'est ça la science, on en connaît plus demain que hier. on peut toujours...
Integrity Science, one more question on a status of what the window team chose to observe for crew choice.
Je vous mets cette petite vue de la NASA, mais voilà. Peut-être qu'ils vont nous montrer l'équipage. Bon, je vois que ça a lancé des théories là.
Window 2 talked about Vavilov, looked for suspended dust, and the Terminator, and window 3.
Qui est devenue l'autre planète? Finalement, l'autre planète, en fait, elle s'est agglutinée à la Terre et les débris qui ont été éjectés suite à cet impact en ont fait... Ça a créé la Lune, en fait.
Features going off to the southwest, the two large, almost look like scratches in the surface. I don't know if they're rays or canyons or collapsed lava tubes, but two distinct features that are almost parallel going off southwest from Oriental Basin.
Est-ce que la Lune a la taille requise pour être considérée comme une planète, demande Elgate Mibiti. C'est pas un problème de taille, c'est surtout un problème que la Lune elle tourne autour de la planète Terre. Et donc les planètes ont plus de problèmes de taille, puisque certaines planètes se font déclasser. Pour X raisons, il faut tourner autour du Soleil. Donc la Lune ne sera jamais une planète.
Speaking of crater rays. The crater rays that are going off to the north,
Galaxy qui dit que se passe-t-il si les moteurs lâchent lors de l'insertion dans la trajectoire vers la Terre ufotinique? Il n'y a pas d'allumage pour revenir sur Terre, donc il ne se passera rien. C'est simplement la gravité qui va faire son œuvre.
They're all small and they look like, you know, a big impact launch rocks and things that make smaller impacts down the way. But something very interesting.
Alors par contre, il y a des allumages pour information de correction. Pour aller voilà, pour corriger la trajectoire, pour affiner l'amérissage. Sachez qu'il y avait aussi des allumages de correction qui étaient prévus pendant l'allée, mais qu'il n'y a pas eu besoin. L'injection translunaire a été tellement précise qu'il n'y a pas eu besoin d'effectuer de correction. Donc les moteurs servent quand même. Dire qu'ils ne servent pas, ce serait un mensonge. Donc il y a bien des allumages pour la trajectoire de retour, mais ce sont des corrections de la trajectoire. On n'a pas besoin d'allumer autour de la Lune pour revenir sur Terre.
Thanks for the description.
Yeah, you're welcome. And integrity is easily identifiable with the naked eye from this point.
Ça débat sur la définition de la planète Terre, mais d'une planète, mais sachez que même les astrophysiciens se sont embrouillés sur le déclassement des planètes. Donc le débat est toujours ouvert. Il y a des questions autour de de ça. Donc vous avez le droit d'en discuter.
If you look just to the right of the Terminator, that is the difference between light and darkness on the moon. You can see what he's describing when he says Hertzsprung Basin and how it looks a little bit paved in the middle there. It's almost in the very center of the moon in this view, coming from the Orion spacecraft and a camera mounted on its solar array.
J'aime bien aussi comme les gens ont une attitude de vous donner des réponses genre c'est la vérité, alors que même des cosmologistes spécialistes de la Lune ne sont pas sûrs de certaines réponses. Comment vous faites pour donner des réponses aussi sûres de vous sur ce qui s'est passé, alors qu'en fait c'est encore en débat?
However, we will regain communication with them approximately 40 minutes later.
Et on est minuit tout pile, 44 minutes encore avant la perte de communication avec la capsule. Donc on a, pour l'instant, on est ici. Et j'espère qu'on verra le coucher de Lune à ce moment-là, de coucher de Terre, pardon, à ce moment-là. J'espère que la caméra sera bien positionnée. Et on a encore 43 minutes à attendre.
And they are looking for the crew to describe the topography of features along or near the Terminator. They're also looking for more information on any color or tone variations, and they're hoping that the crew will take images to illustrate their findings. Glover reported earlier that the crew has missed none of their targets when they are photographing at the window. We aren't hearing the conversations that the crew is having right now, but these are being recorded to their personal computer devices, PCDs, and those will be sent down to the science team. The science team will have a conference with the crew tomorrow morning to discuss their findings and experience when looking at the moon today. I have a few minutes left while the crew is discussing the Terminator. And if you're just joining us, you're looking at a live view of the moon, our moon, from the Orion spacecraft and a camera on its solar array. Inside that spacecraft, 4 astronauts, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen, the first 4 people to fly around the moon in over 50 years.
D'ailleurs, est-ce que vous savez d'où vient le mot planète? Parce que je vois que ça débat de la planète. Ça vient du grec. Planétes, ça veut dire en mouvement, les amis. En fait, c'est parce qu'on était en opposition aux étoiles. Les étoiles étaient fixes dans le ciel. Et ils se sont rendus compte qu'il y avait des étoiles qui bougeaient. Et donc, ils les ont appelées planètes. Ils étaient pas bêtes, ces Grecs. Hein. Ils en ont découvert des trucs quand même. Et puis c'est un bon débat les planètes parce que sachez-le pas, ça change tout le temps. Parce que par exemple, la définition des planètes d'aujourd'hui, vous pouvez dire qu'elle date de longtemps, elle date de 2006 seulement. Donc ça fait à peine 20 ans qu'on a fait une nouvelle définition des planètes parce qu'on a introduit la notion de planète naine, par exemple. Donc vous voyez, c'est pas quelque chose d'aussi immuable que ce qu'on peut penser. Et c'est d'ailleurs tout le débat qu'il y a eu récemment, là, au 21e siècle quand même, donc notre siècle, parce que en fait, on a découvert des gros objets dans la ceinture de Kuiper qui sont plus grands que Pluton, qui était alors considéré comme une planète. Donc ça a poussé l'Union astronomique internationale à se dire il va falloir qu'on forme une définition plus précise de ce qu'est une planète. Donc effectivement, vous l'avez dit dans le chat, hein, elle tourne autour d'une étoile, enfin on va dire du Soleil, parce que en plus, pour rajouter à l'embrouille, sachez que la définition des exoplanètes n'est pas la même que la définition des planètes de notre système solaire. Mais en gros, une planète, donc, c'est un gros objet de forme sphérique qui a effectivement nettoyé le voisinage de son orbite et qui tourne autour de l'étoile et qui est en équilibre hydrostatique. Voilà. Ça, c'est la définition d'aujourd'hui. Mais c'est intéressant la science parce que c'est vrai qu'on se rend pas compte comme les choses peuvent changer dans des domaines qu'on estime figés. La science n'est pas figée. Il faut se remettre en question, il faut faire preuve d'humilité dans la science, c'est ça que j'aime bien. Moi j'aime bien quand je pensais quelque chose et qu'en fait je me dis ah non, en fait ça va plus loin que ça. Il y a quelque chose derrière ce que je pense encore. Ça va encore plus loin. Et on l'a vécu très récemment dans l'histoire de l'humanité. Pendant des années, Newton était le roi, jusqu'à ce que Einstein arrive avec la théorie de la relativité générale. Donc, ce qu'on sait aujourd'hui, les amis, il faut être prêt à le remettre en cause, effectivement. Pas dans un mode complotiste, hein. Il faut juste faire preuve d'humilité par rapport à nos connaissances et on est toujours en train de repousser nos connaissances. Et donc, ce qu'on a appris à un instant T peut être faux le lendemain. Alors qu'on en était persuadé. Newton et Einstein, je pense que c'est vraiment une bonne image de ce que ça peut vraiment... quand la recherche de la vérité peut aller vraiment très très loin et remettre en cause quelque chose qu'on croit depuis des siècles. Merci pour ton don, FR Warrior. Je suis pressé comme un citron, c'est magnifique. Un changement de paradigme, nous dit Dadjo. Effectivement, Newton n'est pas incompatible avec Einstein, mais Einstein a quand même ouvert une compréhension de la gravité qui est quand même assez qui est quand même assez impressionnante. Après, bien sûr, il est allé plus loin avec l'espace-temps, où là, on est parti dans un nouveau délire.
Had a little bit of a view inside the cabin. As you can see, it is very dark. The crew has turned off the lights, and the light that you were able to see is coming through the window, a reflection of Earthshine and from the moon. The crew is moving into their next observation block, meaning they are taking time to switch cabin and window teams. We've had Reed Wiseman and Jeremy Hansen at the windows taking pictures and making annotations and recording some audio files that will be downlinked later to the science team. Meanwhile, Victor Glover and Christina Cook were in the background serving as support. They were also timelined to enjoy a little bit of their midday meal.
Ils vont manger. Ils vont avoir un peu de temps pour manger après.
Support team becomes Reed Wiseman and Jeremy Hansen. They will be in the background helping with SD card swaps as well as providing those situational reports to the science team. Victor Glover and Christina Cook will be the astronauts at the window, photographing and speaking into those PCDs, portable computing devices.
Nadjo qui demande si j'ai mis ma carte sur la carte SD. Pour ceux qui ne le savent pas, on pouvait s'inscrire, je l'avais posté sur les réseaux sociaux, pour mettre son nom dans la capsule. Et effectivement, il y a une carte SD avec tous vos noms et mon nom, effectivement, et tous ceux que vous avez mis dessus. Dans la capsule, dans la petite peluche d'indicateur de gravité, ils ont mis la carte SD dedans. Et donc nos noms vont faire le tour de la Lune. Ça commence à parler de théorie des cordes dans le chat et il va falloir qu'on fasse une soirée spéciale physique. Hein. On va inviter un physicien spécialiste avec nous et on va discuter de ces sujets qui sont très très intéressants. Mais c'est vrai que quand on creuse un sujet, moi ce qui me fait toujours halluciner, c'est que sur chaque sujet, quand vous creusez, que vous allez chercher vraiment des spécialistes d'un truc, vous vous rendez compte que tout va toujours plus loin. Il y a toujours un nombre inquantifiable de connaissances derrière un truc. Et c'est un peu comme un oignon qu'on épluche. On a une première intuition. Et puis après, on commence à apprendre quelque chose. Puis apprendre encore quelque chose. Puis apprendre encore quelque chose. On fait, oui, mais si c'est ça, alors attends ça. Et on descend comme ça dans un puits sans fond. Donc pour les gens curieux, la science, c'est un puits sans fond. Hein. Il y a trop de choses à savoir.
Also be looking for any impact flashes. These are short-lived flashes on the lunar surface caused by impact bombardment. Just before Earthrise, the crew will be looking for lofted lunar dust. This may be lofted just above the lunar surface, and we could only see it just before Earthrise along the dark western limb. Any Earthshine would illuminate potential lofted dust. But once the crew is all the way around the Earth, the brightness of the Earth will wash out any of that dust they might be able to see.
Mais si vous voulez vraiment ne plus dormir, vous pouvez aller voir la physique quantique. Ça peut vous empêcher de dormir. L'horizon des événements d'un trou noir, c'est quand même pas mal aussi. Ça peut t'empêcher de dormir. Voilà. Ça, c'est les trucs quand vous êtes chaud. Vous avez envie de partir dans une petite soirée loufoque dans votre tête. Hop! Vous vous lâchez sur ces sujets-là. Et là, vous ouvrez tout un pan de trucs. Faudrait que je vous fasse une vidéo sur est-ce que le...
That's because we are also anticipating the crew seeing an eclipse today. The moon won't be in view because the team here in Mission Control Houston will need to change the attitude of the spacecraft and ensure that it's
Donc ils nous disent qu'il y a un moment où les astronautes ne verront plus la Lune parce qu'ils vont changer l'attitude du vaisseau en prévision justement de l'observation de l'éclipse lunaire, hein, au moment où le soleil passera derrière la Lune, d'un point de vue de l'équipage bien sûr. Et donc ils vont changer l'attitude de la capsule, et donc il y a un moment ils auront plus de vision sur la Lune, ça va leur permettre d'aller manger, etc., de se reposer un petit peu, parce que eux aussi sont sur le pont depuis un paquet de temps, puis ils observent la Lune depuis 20h45 sans discontinuer. Et donc oui, en ce moment je me suis plongé dans un truc, faut que je vous en fasse une vidéo. Il y a quand même des gens très sérieux, beaucoup plus sérieux que nous, dont c'est le métier, qui font des expériences pour savoir si l'univers est une simulation ou pas. Et donc il y a des gens qui ont des hypothèses sur comment on pourrait voir de manière détournée si c'est une hypothèse ou pas. Sachez qu'il y a des satellites et des instruments scientifiques sur Terre qui testent ces hypothèses-là. Et à chaque fois je creuse, c'est assez fascinant les amis. Et je pense qu'il faudrait en faire une vidéo entière sur ce sujet-là. Rien que pour la créativité humaine, d'être capable d'imaginer autant d'hypothèses sur un point de départ et de vérifier en fait si c'est vrai ou pas avec des instruments scientifiques dans des satellites. Et ça c'est quand même balèze. Je pense franchement qu'une vidéo là-dessus c'est plutôt pas mal. Mais si vous voulez, je vous dis, la physique quantique, l'horizon des événements, c'est deux sujets très sympas pour ne plus dormir et réfléchir à des choses qui vous empêchent de dormir. Est-ce que Mars est habitable ou pas ? En l'état, c'est pas habitable. Alors ça dépend ce que tu appelles habitable. Habitable, respirable pour nous comme sur Terre, ou habitable, on s'enterre et on crée des habitats souterrains. Dans le deuxième cas, c'est habitable. Ça demande pas mal de techno, pas mal d'argent, mais c'est habitable. Mais comme la Lune finalement va être habitée, on l'espère, avec une base permanente lunaire.
To make out, but on the left there, that is Jeremy Hansen just calling down some well wishes to his family, joining us in the viewing room and watching online. Currently in the window are Victor Glover and Christina Cook. They are taking pictures outside of the window as they are now in their flyby observation block.
Et donc je viens de créer des insomniaques à cause de ces questions. On fera un live spécifique physique quantique, théorie des cordes, horizon des événements. Tout ce qui peut vous empêcher de dormir, on fera un live exprès. On fera des lives comme ça, vous savez quoi, pour Halloween. C'est des lives font peur. En plus, c'est comme le chocolat, ces sujets. Faut y aller un petit peu par petit peu. Ah, bah on les voit, là, ils ont rallumé la lumière à l'intérieur. Ah, ils sont encore en train de prendre des photos, quand même. Alors là c'est la capsule. Est-ce qu'on a des photos de la Lune? Ouais, vous préférez quoi? La photo de la Lune? Enfin les images de la Lune en direct ou de l'équipage? Dites-moi dans le chat. On est actuellement à 7117 km d'altitude par rapport à la Lune. Et on va bientôt passer derrière d'ici une trentaine de minutes, un peu moins. L'équipage, la Lune, oh là là, les deux. Ah, vous êtes plutôt équipage, hein. Moi je suis plutôt Lune. Hein. Je suis plutôt Lune moi parce que c'est la Lune. Hein. Bon ok, l'être humain. Ah voilà, voilà la NASA, merci. La NASA en fait sont sur le live Fotini qui sont en train d'écouter, du coup ils ont fait les deux. Voilà. Je les ai soudoyés. Je vois que les trous noirs ça vous passionne aussi, hein. C'est assez passionnant les trous noirs. Est-ce que vous avez regardé la série, je crois, avec Stephen Hawking, peut-être sur Disney+, ou National Geographic. Je me demande si c'est pas Genius, le nom de la série. Peut-être je me trompe, hein. Mais il y a une série avec Stephen Hawking sur tous ces sujets-là. C'est assez intéressant, c'est un bon point d'entrée. Il y a beaucoup de il y a beaucoup de choses qui sont abordées. Le temps, l'espace, les trous noirs. Le voyage dans le temps, il aborde également. C'est vraiment très intéressant.
So starting 5 minutes before Earthset and loss of signal, the science team will capture a series of photos, one every 30 seconds, to include Earthset all the way through 5 minutes after Earthrise and acquisition of signal. In order to capture these frequent photos, the solar array camera that we were streaming will need to switch to time-lapse photo mode. So during this time, the streaming video quality won't be as sharp as you have it right now, but we want to ensure that the science team captures the data that they need during these time frames. And we really look forward to seeing those higher resolution images once they're available. But with the view you are seeing right now, we are sharing bandwidth on the Orion spacecraft with every system that is keeping the spacecraft powered and the crew alive, especially the environmental control and life support system. As this is the first flight with crew, this is also the first flight of a life support system, keeping the crew healthy and safe on the way to the moon and the way home. On the timeline, we're getting towards the end of the cabin and window team swap period, but it looks like our astronauts, Victor Glover and Christina Cook, are already photographing the moon outside of those windows. The next target is Ohm Crater, and this is something that they have photographed previously during the flyby. This is a small complex crater with a prominent.
En fait, je dis, ils ont allumé la lumière, mais c'est la lumière de la Lune. Par un hublot derrière, non? J'ai du mal à voir parce qu'il est en train de manger juste devant. Il est en train de taper sa meilleure boîte de thon, je vous le dis, moi. Those different lighting conditions help expose different portions of the target. Donc ouais, c'est probablement la lumière de la Lune derrière. Bah, ça éclaire fort, hein. Pourtant, ils doivent avoir une demi-lune, là. Parce qu'ils ont dépassé le Terminateur. Benji, salut Benji, merci pour ton nom. Salut, j'ai 2 autres questions. Font-ils un atterrissage sur la Lune? Non, aujourd'hui, c'est juste un survol de la Lune. Et autres, combien de temps sont de retour sur Terre? Ils seront retour sur Terre, pardon, dans 5 jours. On fera le live, bien sûr, pour le retour sur Terre. Qui est prévu exactement? Je reprends mes petites notes. Tac, 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 tac. Hop, la séparation du module de service, ça sera le 11 à 1h33 du matin. 1h33 du matin le 11, donc c'est samedi. Donc ça sera dans la nuit de vendredi à samedi. Et l'amérissage est prévu à... Tac, 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 tac. 2h07 du matin le 11. Ce sera un samedi, le lendemain on pourra dormir, faire la grasse mat. C'est bon.
They have turned the lights off to allow them to better get photos of the moon, preventing any reflections from coming in from the spacecraft. We expect the crew to be targeting Ohm Crater for another 6 minutes or so before they move into a discussion of the limb. Now, the science team has asked for a science sit rep or situation report during that time, so we hope to hear calls from the crew on what they are observing. If you've been following along, at the start of the day, we did have much more of the moon visible. And even just an hour or so ago, we could see about half of the moon. We are now continuing to see more of the far side and that darkness where the moon is not reflecting light from the sun. Earlier, we were also able to see some of those darker portions, that old lava flow that we often see on the near side of the moon and that we can all see from Earth. That has mostly gone away. We are now just seeing very little of Oriental. That's down to the bottom right of the moon. You can see just a small...
Et témoin 10 minutes avant... non, témoin 20 minutes, pardon, avant la perte de communication avec l'équipage. J'espère vraiment qu'ils vont nous montrer un coucher de terre. Merci Spleen pour ton don.
We are now about 18 minutes away from loss of signal with the Orion crew.
18 minutes, on vient de nous prévenir.
Again, we use the Deep Space Network to communicate with the crew members when they are this far from Earth. This is the first mission since Apollo when we have had humans on the Deep Space Network.
Et c'est la première fois depuis la mission Apollo que la NASA a des humains aussi loin derrière la Lune en communication avec le Deep Space Network. Je vais essayer de vous l'afficher.
As you recently heard Capcom Jenny Gibbons call to the crew, we expect their closest approach to the moon to be at MET or mission elapsed time of 5 days, 25 minutes, and 34 seconds. At that time, their altitude would be 4,067 statute miles above the Earth's surface. Just over 2 minutes later, they will reach their maximum distance from Earth. At mission elapsed time, 5 minutes, 5 days, 27 minutes, and 39 seconds.
Le Deep Space Network de la NASA, vous pouvez accéder dessus, vous tapez Deep Space Network sur Google, vous allez le trouver. Et donc on a Juno, JWST, James Webb Space Telescope en communication avec Madrid, Goldstone, et c'est Canberra actuellement qui est avec 2 antennes et en communication avec Artemis 2, Art2, voilà, et qui sont en communication avec la capsule. Et on voit des informations, le vent, l'élévation, l'azimut de l'antenne. View Spacecraft. Ah, on peut voir Spacecraft. Oula, je vais tout casser là. Mais comme ça vous donne une petite vision des antennes de nos amis de la NASA, le Deep Space Network. On communique toujours avec James Webb Space Telescope. C'est dommage, j'aurais bien aimé qu'on voit le débit. More details. Ah, c'est 6000 ou 6 mégabits par seconde là?